wieder auf.
Bleiben wir am Einser.
Ja, bitte. Das war kein Unterschied. Ja.
Eins, zwei, drei, vier. 1, 2. Ja, okay. Dann bleiben wir mit dem Einser. Ich spreche da jetzt aber alle 4 Mikros einmal kurz an,
Ja.
damit wir einen guten Pegel haben. Okay.
Den Ton schaltet sie ein, danke. Hello, good morning, ladies and gentlemen. A very warm welcome here from Vienna, from the Chamber of Commerce. But also a very warm welcome to all participants of this workshop all over the world. I heard there are about 1,000 people watching our live stream now. My name is Reinhold Lindner. I'm a building engineer and at the one hand, and on the other hand, I'm a speaker of a marketing platform in Austria which is dealing with mineral building materials. Our workshop today is called Building Integrated Photovoltaic as a New Source of Energy for Building and Cities. And I want to remark that our workshop is hosted by IPO, the Austrian Institute of Healthy and Ecological Buildings. Ladies and gentlemen, as we all know, climate protection and sustainability are key issues of our time. Concerning the fact, we will focus today new technologies for improving the energy environment performance of new buildings and to regenerate by extending the practice of sustainability constructions. One pioneer dealing with these subjects will guide us now through the next hour. It's Karin Stildov. She is an associated professor and of sustainable building at Vienna University of Technology. Her research projects and publications focus on holistic design methods in architecture, based on building physics and building ecology, and using building simulation systems as design decision support. She's director of a master course program at Vienna Technical University and gained international experience by working for International Energy Agency, also at EU research projects. a board member of Innovative Houses. She is also the winner of several awards, including the Austrian State Prize for Excellent Sustainability Architecture, the Energy Globe Award, and the US Solar Decathlon. So for her innovation is most important for fighting climate change. Ladies and gentlemen, let me welcome Ms. Karin Stildov. She will now start our workshop. Very warm welcome, the floor is yours. Thank you.
Well, many thanks to Reinhold Lindner for announcing a colorful word and introducing our workshop on building integrated photovoltaics, which will be essential for leaving fossil fuels behind. We are 6 experts who will work on a joint research project on Pipv. We come from quite different areas of building and planning and would like to give you a holistic view of Pipv in this workshop today. I will start with my view of Pipv and, above all, examine the architectural aspects. Well, my first graph shows the annual installed capacity of Pipv systems in Austria up to 2020, as well as the cumulative capacity. We could see a start of a very dynamic development of Pipv systems in Austria up to 2020. We could see the start of very dynamic development of photovoltaics, and we are convinced that it will continue like this. Well, affordability. We have seen the average costs of rooftop systems up to 100 kilowatt peak sinking in Austria and Germany in the last years and settling at a little above 1,000 euro per kilowatt peak in 2019. But they are rising again, and they will probably rise more. Why? The costs for substructures and balls have become dominant. Yet, this is also a chance for Pipv. Utility rate scale Pipv from PV parks costs about the half. The average price is approximately about 570 kilowatt peak. There are good perspectives, though, in Vienna concerning PV. Vienna has decided to become a PV model city, the Solar City Vienna. The aim to manage the planned 5-fold increase of PV power in only 5 years, which really is a challenge. It really is a challenge. In order to achieve this demanding goal, you need not only commitment and conviction, but also a budget, companies, skilled workers, and enough material. The energy base shows building integration of PV in Vienna impressively. With Europe's energy performance of buildings directive, solar and highly efficient buildings are becoming the new standard presented here. Well, more impressions. This is the Pipv facade of PV Research Center in Jülich in Germany. Well, let us come to the design of BIPV cells and have a look on the fascinating bi-mode project of Astrid Schneider from 1999. Colored solar cells and shape variations make PV visually and architecturally really attractive. These were the prototypes of hexagonal solar cells and modules with green, gray, blue, and silver color. And here, prototypes of triangular shape and models with blue, golden, red color designed by Professor Klaus from Cologne Media Art School, produced by BP Solar. Let me show you more. These are printed and frosted front glass and colored at the back. They cover, this is a view of a multifamily building in Switzerland, and here the modules cover the whole building envelope. Well, back to technology. Let's have a closer look to different kinds of PV modules. We have here monocrystalline solar cells, glass, laminate, at the left colored coated front glass, back glass with color, email or other means. On the right side, screen printed on outer surface of top layer with glass colors. Here, another beautiful example of BIPV used for the Copenhagen International School. The installation in different angles allows various reflections and color appearance. And having a closer look to the modules which are color-coded, or which have a color-coded front glass. This is an opportunity to use BIPV for the building stock, brick-colored solar roofing elements. Here the zero energy hotel house of choice with screen printed BIPV in Stockholm. And the shading louvers above the atrium of parliamentary and office building. They have amorphous glass solar modules. Well, the last example which I want to show to you is a glass roof with a semi-transparent BIPV, the House of Culture in Moscow by architect Renzo Piano. A beautiful room with a very impressive BIPV installation. Well, let's come to finally to the future of BIPV. How should it go to really have a good future and to realize it? Most important, BIPV mass produced for mass markets, glass roofs, shading and facades, so the whole building envelope, being able to produce the whole building envelope in a mass production. Standard BIPV should be as cheap as standard modules. BIPV should be integrated in the construction of facades, roofs and glazings, and individualized BIPV for attractive architecture. We have Airtech Solar, who has done a lot of the installation for honored projects, like the one in Switzerland we have seen before. Smart Solar City Tech with energy communities and share, and BIPV industry back in Europe. That's very important because there will be really a great demand for all this for this technology. Well, and in the end, still worldwide collaboration and unified standards for BIPV. Well, thank you for your attention.
Thank you very much for your presentation. Thank you.
Thank you.
We will follow now.
After this first overview over BIPV projects, I would like to give the floor to Christoph Trebersberg from Trebersberg Architects. He will join in now with more architectural impressions of sustainable buildings with PV from his office.
Thank you very much.
Thank you, Karin.
Just a moment, we will check the technique. Yeah.
Very good. My name is Christoph Trebersberg from Trebersberg and Partner Architects. We are an architecture company based in Vienna with a special focus on green, sustainable and ecological architecture for over 30 years. The sun as a source of inspiration and energy in buildings can be traced back 1,000 of years. Actually, the discussion might be as old as the genre of architecture itself. A very good example for this design practice is the solar house of Socrates, documented by Xenophon. The house is orientated to the south, as you can see, and the design is in a way that the low-standing winter sun can enter the house, bringing light and warmth into the deeper core of the building. In the months of summer, when the sun is high in the sky and very strong, the house provides shadow and shelter for solar impact. This is basically the concept of passive usage of solar energy. Amongst the vast variety of other important topics like social aspects, good design, and great living comfort, this is the basis for the architecture we are developing. In recent years, computer-aided design and parametric software made it possible to implement solar design to buildings with a greater precision than before. The kindergarten in Burgersdorf is an example for this.
No, it's not possible. I'm very sorry.
The next slide will be clearer again. The building is located in the north, next to a tall housing complex casting development of kids. So one of the biggest challenges was to bring sunlight into the building. With digital design tools, we modeled the surrounding and simulated the movement of the sun throughout the years and the shadow being cast. We optimized the geometry of the building to bring sun into the main group rooms using these technologies. The result of this form-finding process is a building geometry with two light catchers, which we can see here, these high points. We also see like the living complex next to it, bringing light into the building, even in the darker winter months, as we can see here. So with these simulation tools, we have the opportunity for a very accurate planning and design process with light. The Schistle House is another project I would like to show you. It's located on the Hochschwab in the height of around 2,150 meters under extreme conditions. The whole area of the Hochschwab is part of the Wiener Hochquellwasserschutzgebiet. This means that the tap water of Vienna is collected in this area. In former times, the energy in form of oil or fuel, which was delivered to the old Schistle House, had to be flown in by helicopter. This kind of supply always poses a risk of a crash with severe consequences for environment and the water supply of Vienna. Through the use of solar energy, this time in an active way with PV panels, the new Schistle House can ensure self-sufficiency under these extreme conditions. The Doppelhaus in Vienna can be seen as a kind of prototype for future living, at least concerning its energy concept. The building is heated and cooled by a thermal activated building structure. In the concrete slab, tubes are located using the concrete as a thermal storage. The system is connected to a heat pump with geothermal heat sources. In combination with an optimized building envelope, the building is a passive house. Very little energy input is needed to cool or to heat the building. Solar panels provide the electric energy to power the heat pump, whilst also the passive and solar inputs and the natural ventilation is used. To control this complex system, we developed in cooperation with the University of Bodenkultur in Vienna an algorithm which is looking 2 days into the future by using weather forecasts. And this algorithm is optimizing the system, providing the highest comfort with the lowest energy consumption. This house is scientifically monitored in several research projects, and we always thought of this idea as a demo project which needed to have a scale up and being brought to a broader audience in the field of social housing. At the moment we're working at the Campo Breitenlee. This is a project with around 220 flats and a kindergarten fulfilling the criteria of social housing in Vienna. The energy concept is more or less the same as the one in the Doppelhaus in Burgersdorf, so this can be really seen as a scale up. With a power input of around 700 kilowatt peak through integrated photovoltaic modules on the roof and also on the facade, the Campo Breitenlee, could be one of the first plus energy quarters in Vienna, and therefore a big step into a green self-sufficient future of the city. The integration of PV elements into facades can also help in retrofitting the existing building stock, one of the largest challenges in architecture right now at the moment. The building complex in the Hütteldorfer Straße, built in the early 70s, was turned into a passive house, cutting the energy consumption by up to 90%, also using building integrated photovoltaic. In the future, the skin of our buildings will be able to produce the energy we are consuming. Building integrated PV will take over a multitude of additional functions, like the balcony PV in this project, the Hirschstädtner Straße, which is delivering privacy and working as an element providing shadow. And in this case, building integrated PV will be a substantial part of our future's architecture. Thank you. I would like now to introduce the next speaker, or maybe Karin, you could do this.
Well, we have a joint presentation, and the next, I think, is Astrid? No, sorry. So, no, sorry, Markus Speichner from Kyoto Solar. Well, perhaps to have a few words on, we are planning a project, or we have given in a project, and this is the team of our project, and Markus Speichner from Kyoto, the biggest producer of PV cells in Austria, just on his way to a conference in Munich.
Exactly. Very warm welcome from my side as well. Karin, thank you very much for the nice introduction. I'm Markus Speichner. I'm in charge of product innovation and R&D at Sonnenkraft and Kyoto. For those of you who do not know Sonnenkraft, we are one of the biggest system providers for heat, water, and energy in Europe. We are an Austrian company with headquarters in St. Veit an der Glan and a second production facility in Wernersdorf in Styria. In St. Veit, we produce our main photovoltaic modules, our freshwater stations, and our heat exchangers. At our second facility in Styria, we focus on the production of glass photovoltaic modules and special modules. As you might see on the slide, we try to produce our products as environmental friendly as possible. For example, all or most of the energy needed for producing our products is produced by the photovoltaic power plants at our rooftops or at the flat roof at the end of the facility in St. Veit, which was installed last year. So this is one of the nice examples how building integrated photovoltaics can be realized. You will see a picture of this building at the end of the presentation as well. Furthermore, other steps to become more environmental friendly is, for example, we have programs to optimize the waste management and the recycling processes of our products at the end of the lifetime. Sonnenkraft and Kyoto is a provider of innovative solutions for the building envelope, starting from standard on-roof photovoltaic modules over in-roof photovoltaic systems to overhead installations, for example, for terraces or carport systems. We even can produce sun facades, where you will see some examples in the following slides. So all these building integrated photovoltaic systems have a huge potential, and these systems, all these applications will even be needed to achieve the renewable energy goals of Austria, of Europe, or even globally. In our point of view, every building, every house has the potential to become a power plant for the sunlight. Nowadays, it's possible to include photovoltaics in the cityscape without interrupting the cityscape itself. At this example, for example, at the house or the facade of the house in front of the picture was realized by gray photovoltaic modules. So in the first step, you do not even see the photovoltaic modules, but the complete facade supports the provider, the house owner, to minimize the external energy costs and to produce environmental friendly energy. One important thing which needs to be done when photovoltaic or building integrated photovoltaic systems are installed is that the photovoltaic concept needs to be thought right from the beginning. So the photovoltaic needs to be included into the planning process right from the beginning. One nice example can be seen here. This is the AVL hall in a list in Graz. Here, right at the beginning of the planning process, the photovoltaic facade, the black one, was included right from the beginning, and it's aesthetically possible to include photovoltaic in your building envelope. And as I said, to reduce your energy costs. With these words, I would like to finish the presentation. Maybe one more thing to say. As I said, building integrated photovoltaic has a huge potential. To really get this potential, we need tools to make it more easy to include photovoltaic in the planning process. And one of the goals of the research project, together with all the partners you see during this workshop, is to get a basis to make it more easier in the future. So thank you very much for your time, and I wish you a nice day at the GreenTech Days.
Well, Markus, thank you very much for the very interesting insight into the activities of your company. And I would like to welcome Astrid Schneider from Solar Architecture. She has devoted all her professional life in the end to photovoltaic, and she will present now a very specific photovoltaic solution.
Thank you very much, Karin Stildov. Thank you very much for WKO for inviting us here to host this workshop. We are very grateful for this, to show you more about building integrated photovoltaics. Yes, my name is Astrid Schneider. I'm architect and specialist on photovoltaic building integration and solar architecture. And on the left-hand side, you see already a product I have been developing, the solar window shutter, and I go more into it. I have been doing a lot of publications as well. Already in 1996, the book Solar Architecture for Europe, and have been working on the Solar Government Quarter in Berlin. And on the right-hand side, I would like to highlight there's a book we have been putting together recently with the International Energy Agency, and you can download it for free when you follow that link. It's with about 50 examples of all over the world of the latest building integrated photovoltaics. Yeah, this is just a little showcase of the work I have been doing as an architect and as a specialist as well as a consultant. And let me just go into the subject. So this is a historic house which is monumentally protected. And here you can see we have integrated, I just can go here as well, solar window shutters, which are my work and my invention. But as well, all the roof, you see here, all the roof tiles are photovoltaic, solar roof tiles with monocrystalline solar cells. And this is exactly what we are aiming to in this project, to do more detailed, more integrated planning with the architecture. Here you see more details of the solar window shutter, and you see it has a wooden frame, it has gray multi-crystalline solar cells. It is a glass module, so it can be opened and closed, and at each time with a special mechanism, the solar active area is facing outside. You see it is closed, it's just the same. Here you have a view from the inside, and here you can see it's even doing very nice shades. And it should give a good daylighting as well for the room, because it's very important that we do not only shade, but as well daylight our rooms, as Mr. Geisler-Moroder from Badenbach will point out in a minute. And here you see a close-up, so it's as well more environmentally friendly to have wooden frames. And as told earlier by Mr. Trebersberg, we need to refurbish buildings, so we need to do more sensitive, more adapted solutions. Here's a second example of the solar window shutter. This was as well a historic building which was fully refurbished. So there's heat insulation which was put into it. And then you can see here the solar window shutters again, opened and closed. As well here on these windows, you see some louvers which are giving some shade. But not only in the facade, we have integrated the photovoltaics. This reflects the roof, so all the roofs are full with this kind of integrated solar roofing system. So this building produces as well about as much energy as is consumed in the building. And sorry, it's so much. And here you have a close-up, so you can see the window shutter should be multifunctionally, so it can be fully closed and it's as well weather protecting. It can be opened for sure, so that, for example, in winter time you can enjoy all the daylight and sunshine you would like to have into the room, like the passive solar architecture to have the heat gain. But as well, for the summer case, there's a ventilation positioning where it's about 10-15 centimeter in front of the facade, so that you can have natural ventilation and shading and daylighting at the same time, what is very important. And here you can see the same three positions from the inside. It looks like this. These are the big windows on the top, so either you can fully close it, or you put it to this ventilation position, or you open it. And you can imagine in the winter time, you get all the sunshine and daylight you want. Yeah, so this is another example. So one theme of our common research project will be how to plan these things, how to calculate the passive solar gains, the daylighting of such elements. And here is a very interesting perforated monocrystalline cell, and you can see that it makes a soft shade. Earlier on you have seen a hard shade, but this is now a soft shade. So this is, for example, much better for office buildings where you do some computer work. Yeah, here I had the chance to present this solar window shutter at the expo in Japan with integrated LED. And so in the nighttime you can see it can shine as well in different colors or give some very nice lighting for your room. And yeah, with this I would like to finish. So the solar window shutters can do perfect daylighting, solar electricity, shading. It can be a design element for your building. And in this project, BIM for BIPV, we are aiming to do a complex planning and designing with all the disciplines collected. And with this, I would like to thank you for your attention. Thank you.
So
Yes.
Astrid, thank you very much for the presentation. We could see how many applications are possible with PV, and maybe there might be a solution also for solar shutters in Vienna as well. We have already one in mind. So welcome David Geisler-Moroder from Bartenbach, famous Bartenbach Lichttechnik. I really wondered if somebody doesn't know about you. So this will be the light issue of our presentation today.
Thank you, Karin, for the introduction, and thanks for welcoming me here, and thanks for organizing this workshop and for inviting us to the project BIM for BIPV. We're really happy to join that project and to bring in the daylighting part and advocating for daylighting. And this is also what I would like to talk about in my presentation. I call it daylight utilization in BIPV. It's an area of conflict, but it also gives us chances in bringing this together in the facade. It is obviously in conflict. We are like struggling, who is getting the sunlight, who is getting the daylight? Is it the PV or is it the daylight in the room? So for those who don't know our company, Bartenbach, we are a lighting design company from the start, founded by Christian Bartenbach, our senior chef. So we are doing lighting design independent from manufacturers. We're around, that's like some month old, we're around 95 employees at the moment, about 45 doing lighting design, and about 25 in the R&D department. So this is where we also do the research to gain the knowledge that we need for our lighting design projects, and to also develop technical solutions for daylighting and also for electric lighting. In the moment, everything in LED lighting, so lenses, optical design, reflectors, things like that. We planned in our lighting design groups more than 10,000 projects worldwide already since we started like more than 50 years ago. So I do not show all of these projects obviously, and I don't go into the projects at all. I would really like to show you what is it when we're talking about where are chances between daylighting buildings, daylighting, using the facade for daylighting, and integrating photovoltaics. What is our company doing? It's, as I said, lighting design, for daylighting design, artificial lighting design, research and development. Also, we went that step into complete lighting solutions, meaning we don't only do the planning, the design, but go into the installation, the implementation as well. Materials consultation, this is something very important. People often don't really know that. Looking at the architect in our round, they know that because they need to work with the materials, and we as lighting designers, we also need to do that. There's huge differences that you can gain with materials. And for us, for example, semi-transparent Pipv is something that is a new material that we can use in the design. So what are we talking about today? It's sunlight, it's skylight. And as we all know in here, and this is why we are talking about using PV, it is a constantly available source of energy. It is a constantly available source of light. It is free, it is clean, so we should just use it wherever we can. We should use it. And now I'm playing the devil's advocate for the BIPV part. In my eyes, PV is not that efficient. PV is just taking 20% of what we gain from the sun and transforms it. And even if we take that image, we even lose more energy because we need to convert it in the light source then again into light from electric power into light. So what we want to do and what we do is we use it directly. We use it loss-free, we use it as daylight, and we bring it into the room, and this is where we need to work on. How can we bring that together, that we have photovoltaic installed in the facade, combine that efficiently with optical ideas, with redirecting ideas, and bring that into the room. If we're talking about daylighting, there are different ideas and different demands that we need to fulfill than when we're talking about PV. So it's I clustered it into 3 parts. We have visual demands, that's clear. We need to get in a lot of daylight. We need to really light up our room. We need to distribute it properly. We don't want to have all the light close to the facade, but we also want to have it deep in the room. We need to get glare protection, a very important point, especially for workplaces. But we also, and this is something people often forget if they're talking about ideas for systems, we want to have the view out. People want to have the connection to the exterior. We obviously and for sure have the energetic point. So this is where we get into contact with PV. On the one side, we want to get the energy in terms of electricity, but you also need to think about the thermal and the building physics behavior. We want to get the solar energy in winter to reduce heating loads, but we want to also shade the sun in summertime. And one thing that is a very important point, and that was not really known up to like 15 years before, how important lighting and especially daylighting is for our non-visual system, how light and daylight affects our non-visual system, our circadian rhythm, our perception, our mood. And this is something that is really important. And this, talking about efficiency, on the one side is energy efficiency, on the other side, sustainability only works if people are healthy and if people can work well in their buildings. So bringing that last slide, more like a mind map for our project, what we are now talking about is we have very different approaches and very different fields, and they are all pulling into different directions, and this is what we need and what we need to try and want to try to bring together in this project. In the first step, and this is also in my eyes, the very important first step of every building is the design. Every mistake you make in the design, you will hardly be able to solve it later on. So, final, let it be light. Thank you for the invitation, and thanks for letting me talk here.
Well, thank you for the word wrap in the last 10 minutes.
Well, thank you very much, David, for lighting our mind. And there's no project without without digitalization. And this will be our last last part of the presentation. Welcome Christian Schranz from Vienna University of Technology. This will be the focus laid on building information modeling, which also will help to realize and make photovoltaic issues come true.
Good morning. Thank you for inviting me to this lecture, and thank you for inviting me to this project. My name is Christian Schranz. I'm the head of the Center for Digital Building Processes. I'm also a member of the board of Building Smart Austria, so responsible for developing IFC, and a member of the steering committee for professional certification of Building Smart International. The research activity for our group is to develop the open BIM processes. As I'm a member of Building Smart, I'm looking not only at BIM, but mainly at open BIM, so using open standards. One of our big projects is the open BIM building submission process. You might have heard about it, Prise Vienna, where we try to also make a checking of the BIM model for all the regulations. And one part which we won't use in this project is augmented reality in civil engineering. So some of my guys are also working on that. A few years ago, we started to accompany and analyze a pilot project done by the Austrian government, the Bio-Institute of an agricultural school in Styria. So we were looking at all the BIM process and how we could use all the data. This is a first 3D simulation. This is how the Bio-Institute looks now. The project is finished. And at the time, to be honest, I didn't know Karin Stildov personally very well. So we might have used it a little bit different because they were using a photovoltaic facade, and they might have done it maybe a little bit different if we had more knowledge about it. What did we realize at this time when we talk about BIM? That we can use the whole digital model with all the alphanumeric and geometric information through the whole life cycle. Of course, this building is at the beginning of its life cycle and hopefully will last for a long time. But we could use it at the beginning, as you see here, the common data environment as a project information model during the planning and the building, and now it's going to this asset information modeling being used during the operation of the building. What we could do is also digital exchange of the data, and we try to make as much simulations as possible using the BIM data. We couldn't use the BIM data for the photovoltaic simulations because we didn't have all the data which were necessary. So in our project, we want to use the data for electric, daylight, and energy simulations of all these elements. And we also would like to make the certifications. In Austria, we have a Klimaaktiv certification, which is for energy efficiency and so on. And we also want to use this data to make these simulations automatically out of the BIM model, not to use Excel sheets or to use other programs, and maybe to connect the programs to our BIM model. But we don't have the data, so what are we going to do in the project? We're working on new IFC elements, which you could use especially also for Pipv. We might have used them, to be honest, in the project. And also we are working on new data templates for photovoltaic elements so that we have everything together and can use the digitization in the whole process. So this was a short introduction to why we use BIM or what we want to do. And thank you again for your attention.
Thank you very much. And many thanks for the time discipline. Now we have 5 minutes for questions. Are there any questions in the audience?
Yes, 1 second. My first question is, of course, what do you do at night? You know, is there storage, or is there, you know, what is the solution for the night time when electricity is required? And the second question is, you know, some more than 25 years ago, my university, where I'm teaching, TU Graz, there were some people from another department who went out, like young assistants, who went out to the farmers in the Steiermark, and they taught them how to make their own solar panels. So only the foil was actually mass-produced and bought, but everything else they could do it themselves. And that would, and they also taught them how to repair it and take care of it and stuff like that. Why has that not become a big thing? Because that would enormously increase the number of, like, especially in developing countries.
Yeah, so let me thank you very much. Is it working? Yes, thank you very much for the question. So first of all, during the night, so one thing is for sure, we have the batteries, but I have to say we are not aiming for independence or autonomy of each building for itself. But we had this highlight of smart solar city tech. So we think an integrated cycle, so for example, solar power together with water power and with wind power and with bioenergy. So everything will be in the smart grid and will be connected to each other. So that's a very simple answer. So photovoltaic is one major contribution, but in combination with the other sources. And the self-made, yeah, maybe it will come in the future. I think we are not yet there. At the moment, we talk about high-tech processes for photovoltaic solar cells, especially for the crystalline ones. I think what you have been talking about, what the farmers did themselves, it might have been solar thermal collectors. So we talk, oh, okay. So we talk about photovoltaic here. So maybe one source could be the so-called color solar cell, which might be even available, but with a lower efficiency. Thank you very much.
Well, and don't forget about supply management. This will be very important in the future. When do we use energy? So to organize that will also help much. Not everything is needed during the nights. But of course, there still will be some problems in winter, in January.
Another very low-tech way to store this energy are these thermal activated building slabs, because you can actually heat them up, and like an oven, they store the heat for around like 10 to 12 hours. So that's a very low-tech way to store energy. But what's most important is to see the city as a network, an energy network, which is communicating with each other.
Is there another question? Yes.
Yes, these photovoltaic panels, what will happen with them after the end of their lifetime? They are complicated layers, I think.
Yeah, there's a European project going on which is called PV Cycle. And in the PV Cycle project, they take this question up to recycle solar modules, which is already possible. Even the solar monocrystalline or multicrystalline solar cell, you could reuse it.
Perfect, thank you. We have time for one more question or two. Yes, no problem.
Thank you. My first question is, what is your opinion on what the biggest barrier on bringing more PV on the market? Because now it seems to be still a small amount of buildings equipped with PV. And the second one, we have seen now in your really nice presentation, thank you for that, a lot of residential building projects. Are there any ideas to go for industrial buildings as well, like huge warehouses, or where do you have these huge facades that are currently totally unused?
Well, I think the biggest problem is still are still costs, and I think there the solution will be to have really mass production for mass application. And of course, there are big roofs everywhere in Germany, and especially, and also in Austria, which are covered with PV modules, but they're not that much integrated yet. So there are really a lot of possibilities to apply them better. And we did not show today, but there's a big award in Switzerland where very beautiful buildings are shown, and more really large roofs are covered. They're really very effective. So if you have the chance, look it up. Very beautiful projects with very large roofs.
Yeah, thank you very much for your question. So regarding the warehouses, for example, that's as well an economic question that we get, for example, these energy communities, or that we get the duty to build it, because sometimes you have these big warehouses with so huge walls and facades somewhere on the countryside, but there's not much energy used into it. But when it can be sold to a whole community, to a city, to other people, that is something the European Union is now pushing with the energy communities for people. And it's very important that it will come into force in Austria as well. And it has been coming into force now, I think. So there are now the chances how to do it. And then our project to integrate the photovoltaics into this digital planning process should make it much more easy for architects that they can find just these digital models and put it to their BIM model, to the 3D model of the building. So to make it more available and to push the market. And I personally think that with the building integrated photovoltaics, as well this with Industry 4.0, so Austria is strong on digitalization, right? So that we will have the mass production as well of individualized panels, because we need some more integrated solutions. And what Ms. Stildov said, that photovoltaic industry should come back or is back to Europe to produce here the more adapted and specialized in size and layering solar modules for the building integration. And this we would like to push it as well with our project.
And perhaps not forget about multifunctionality.
And I just want to add one thing to that. I think one possibility is to really advocate for BIPV more from all directions, and that's why we, as a lighting and daylighting designer, also think about these things, how to propose that to building investors, to new buildings. So from our side, but also obviously from the architectural side, to really propose these solutions and bring that in the designs and really advocate for these ideas.
So basically, I think that
we have 2 minutes, it's fine.
yeah.
Basically, I think that you get a microphone.
The government must enable and support, at least in the first 2 or 3 years, mass production of solar panels and BIPV, and also reduce because I wouldn't say Austria is really very Wirtschaftsfreundlich, so we have to reduce many of the regulations which are to do with the medical insurance and all kinds of hurdles which are there in the system from the 19th century actually. So we are living the 21st century and we have to change, otherwise Austria will go down like that.
Thank you. Thank you very much. One last question, very short. Thank you.
Thanks. Yeah, my question is, are there many, not only development projects, but also commercial projects for PV modules on houses which are with historical aspects, so like Denkmalschutz or Ensembleschutz?
Well, I think this really is a challenge to also cope with the Denkmalschutz. But we have worked on a project for Otto Wagner Areal, and the Denkmalamt was quite open for photovoltaics. And there also are roof tiles on the market, specifically from already for a long time in Switzerland, but also we have seen the brick-colored photovoltaic modules, and they can be used very well for refurbishment.
Yeah, that's a perfect handover. I know from several roofing companies who are now looking into the challenge to do adaptive products. And I think the building integrated photovoltaics is now there where the standard PV modules have been 15 years ago. So I think we will face and see this big uptake in production as well in industrial production. Our partner Kyoto is one of them already doing this in Austria.
Just the last point, yeah, as you've seen in the presentation, PV models or the look of PV models is changing rapidly. So there are PV models now just with a single surface without this crystalline structure. So this is a way to implement it into architecture in a very, let's say, sensitive way.
Thank you very much. And yeah, I give the last word to Ms. Stildov.
Well, again, thank you very much for inviting us. Thank you for having us. And we really go for photovoltaic and its application in the world, and I think it will be very important for really leave the fossil world behind. So I think this will lead to a brighter future.
Thank you. Thank you very much. So let's have a switch to the second part of our workshop. Now we have some presentations in the Austrian fields of innovation. Thank you. And timetable is okay. So we start with Ms. Katharina Leb from the company MO Point. The company develops and operates shared mobility, and we look forward to hear about your innovations. Thank you. The floor is yours. Thank you.
Can we switch to the...
Just a moment, please. Go on, get next.
No presentation so far, but at least I can start introducing myself.
Thank you.
So my name is Katharina Leb, and I'm project manager at MoPoint. And I'm really happy to present to you today what we are doing at MoPoint and kind of explain our vision and our new idea of how we can organize mobility in our cities and in our life. So we as MoPoint, actually, we are mainly providing shared mobility services for all kind of real estates, really starting from single buildings up to whole city quarters and residential areas. So now it would actually be good to have the presentation. Okay.
Our technique is working to get the presentation. Thank you very much.
Oh, there we go. Great. Okay. Yeah, there we go now. Great, thank you. So I would actually like to start, not with our vision of mobility, but one step actually before and explain why we're working in the field of mobility and what we are actually doing. So we saw, and unfortunately we still see that the mobility sector is really one of the main issues when we talk about greenhouse gases and emissions. And as you can see in 2015, almost 20% of the greenhouse gases were produced by the mobility and transport sector. If we have a closer look to Austria, it's even worse, it's almost 30%. And what's even more alarming actually is that we still see an increase in these numbers. So while many sectors actually tried to manage to decrease the CO2 emissions, like the industry sector, the agricultural sector, even the energy sector, they had a decrease in the last couple of years. The mobility sector is still having this increase. And if we have a look of where this is coming from, we see that main parts actually are coming from the road transport, and there again by private-owned cars. And if we talk about private-owned cars, actually, there is another big problem, especially in our cities. They just need a lot of space, even though most of them are just standing around 95% up to 23 hours a day, not being used at all. So here we have a huge potential of more efficiency in our cities and in the way how people move around and how we organize our mobility. And that's actually where we as MoPoint come in, because we are developing mobility concepts for city quarters and real estates, as I already mentioned. But not only the concept, but we also implement mobility points or mobility hubs, as they're also called, where we really get together different kind of vehicles and put them in a sharing service. So the people who live in the buildings, who work in the buildings, who are the neighbors of these new buildings, can use the sharing services and don't need necessarily to own their private car. So our goal, kind of our vision, is to get rid of this old idea where we have like each apartment needs at least one parking space or one parking lot, and every person who lives in this apartment needs his own car to move around and get around in the city, instead of having this kind of new idea and this new version where we use all the transport modes, all the transport services we already have or we implement in the new buildings. So to really, that we offer the mobility services for the people whatever they need in their specific situation. And this might not always be the private car. So just imagine to go to the supermarket in the city center. You probably don't need a private car, even though you don't want to carry all your heavy things. A cargo bike might be the right decision, but on the weekend you still want to visit your friends and family, and you still need a car. But that's kind of the idea, having different options for each of the specific situations we are aiming. So for the inhabitants of these buildings, I think that the benefits are quite clear already. But also the property developers and the real estate developers, they can have really big benefits from implementing these new mobility services. Since we know that the construction costs of parking spaces are really high in dense inner city centers, it can be up to 25,000–30,000 euros per parking lot, so quite a lot. And if we try to manage to reduce the parking spaces, we can also reduce the construction costs by far. And last but not least, also the building itself gets some benefits from new mobility services, as the building gets or gains some sustainability, a sustainable image, which is quite necessary or is getting even more and more important, especially when we talk about sustainability certifications for single buildings or whole city quarters, where mobility is really a huge building block and is getting even more and more important in future. So we as MOHAB, as I already explained, we on the one hand really advise you and help you with developing mobility concepts for your building and your city quarters. We evaluate your location. We can show the improvements which you have in your building, but then also really help you with setting up a mobility point, implementing the new services and sharing services, where we help you finding the right types of vehicles for your area, for your building. We provide you with the infrastructure, with the IT platform which is needed if you want to share vehicles. And last but not least, of course, also the big field of the operation. So we take care of the customer service, the fleet management, the incident management. So really taking care of the vehicles which are out there and used by the people. So last but not least, to wrap it up and give you some kind of ideas where we have implemented such mobility points already, is really in residential areas. For example, at Nordbahnhof, which is a quite big development field in Vienna, Marina Tower, but also mixed-use quarters where we have office buildings and living areas next to each other. We have done for IKEA a logistic concept where we have looked into how can we organize to get the products to the people, not using their own cars actually, and also doing the operation for mobility management for office towers like this DC tower. So quite a big field actually, and yeah, thank you for your attention.
Thank you very much. So we also have a little slot of time for 1 or 2 questions. Is there a question, please?
I think the first step that city governments should do is to make taxis, all new licenses for taxis and for delivery vans and for car sharing to be purely electrical cars.
Yeah.
And then slowly also transition to all private cars.
Yeah, like I can just talk now for MoPoint, like 99% of our cars are electric cars. So that's where we really want to go into. So we really try to be sustainable in this field. And we see that a lot of people actually are kind of not afraid, but they're just not used to drive electric cars. And if you provide them in their building, actually, you know, you're getting closer to them, they try it out, that they have like a positive experience, and then they're way more open to electric cars as they used to be before. So it's really important to get it closer to the people, that they have the possibility to try it out and have a good experience with it.
Of course, we all know that electric cars solve only 1.5 problems of the car.
Yeah, that's for sure. But in the combination of sharing and electric cars, we have a huge potential, yeah.
A last short question from my side. There are many sharing services around, but what's the USP of Mobile Point?
Yeah,
Demo Point, sorry.
Yeah. As we heard already, I think we heard there are car sharing services, we know all the scooter services, but all of these operators, they just provide one type of vehicle. So if you want to use a car sharing service and the bike sharing service and the scooter sharing service, you have to register 3 or 4 times, and we all know that it's not really convenient, and then the scooter is there, but you are not registered at that specific operator. And we as MoPoint, I think that's really the USP, I would say, that we have all kind of different vehicles, and we are one provider. You just have to register once. You can use them. They are right in front of your door or even in your building, actually, so the access is just really easy and really comfortable for the consumer.
Perfect, thank you. So let's go to the next speaker, speaker number 2. Thank you very much, thank you. Miss Birgit van Duvenbode, I
yes.
hope it's correct.
Yes, perfectly fine.
Ms. Duvenbode is CEO and founder of a noise, a company which focuses noise protection technology. And yeah, we are very interested to hear your approach about these systems. The floor is yours. Thank you.
Yeah, thank you. Thank you for inviting me today, and thank you that I can speak here. So, hello again. My name is Birgit van Duvenbode. I am founder and CEO of Reduce Noise Protection Technologies. We're a young startup from Vienna seeking to reduce noise, but also environmental problems other environmental problems at the same time. So, let me introduce you to the topic noise. Noise is one of the biggest environmental problems we are facing nowadays. Every 5th European is affected by constant noise levels at home, which is considered to cause severe health damage, such as stress, sleeplessness, but also cardiovascular diseases. So the main sources for this type of noise that makes us so ill are road traffic, railways, air traffic, but also noisy production sites. But what if I told you that not only that noise is an environmental issue, but also the way how we mitigate this type of noise nowadays? In order to reduce this type of noise from these sources, we have to build noise barrier walls. Maybe you know these walls from next to a highway or next to production sites. Only in Austria, we build more than 50 football fields of these noise barriers every year. That's quite a lot. And all of these noise barriers, on the one hand, protect us from the health issues caused by noise, but on the other hand, they create many other environmental problems, such as climate change and a lot of hazardous waste at the end of the lifetime. So this means that all conventional noise barriers we have on the market nowadays, based on the materials wood concrete, aluminium, chemically impregnated wood or plastics, contradict our climate and circular economy goals in Europe. With Reduce, we want to change that. We have developed the first ecological noise barrier technology based on the materials reed, in German this is Schilf, thermally treated wood and clay. We know that this technology works since we can build on the findings of a pilot wall which is standing strong next to a highway since 2008. We have now patented this technology, and we're on the best way to become compliant with all the high norms and standards needed for public streets. Our product will be available from mid-2022 for business customers and 2023 for public customers. While reuse has the same high standards as all the other conventional products on the market, it offers many more ecological benefits. It is made from ecological and regional raw materials. For instance, the reed we take from Lake Neusiedl, where it is actually currently an environmental issue because there is no use for it. It also serves as a CO2 sink, so meaning every square meter of a wall can actually store CO2. It is built according to the circular economy and does not produce any hazardous waste at the end of its lifetime. Also, the clay inside can bind fine dust and improve air quality on streets. And it also serves as an insect hotel, improving biodiversity. So, if you're curious to learn more about reuse, about our products, or about the building material reed in general, please don't hesitate to contact me, write me an email, call me up, or meet me at the coffee. Thank you very much.
Thank you. Are there any questions?
Well, it's a very nice project, and I really love to hear that you use clay. But how do you manage weather protection for the clay? I think this is an interesting question.
Yes, thank you for the interesting question. Actually, the clay is inside our noise barrier. It is the insulation of a noise barrier. Normally, you use insulation materials like, classic ones that are hazardous waste. But the clay is inside our wall. So we can see also on the pilot wall that this does not affect the clay at all because it is protected by the reed outside. Yeah.
Thank you. I think here's another question.
Because this is biological material, how long is the lifetime? Does it get rotten very quickly?
Yes, thank you. That's a very nice question. As I said, we adhere to the high norms and standards that are needed for all noise barriers in Europe. And the durability says that it has to last at least for 20 years. However, I already mentioned that we also have a pilot wall that we can build on, basically, standing since 2008. And you can observe on the highway that it had a better performance up to today than, for instance, the wood concrete wall in this area. Yes. So we are also looking at the material reed. We really found the power of this building material because it is very durable. For instance, looking at reed roofs, maybe some of you have seen it already, can last 60 years or longer, and it does not need any impregnation or whatsoever. So we are optimistic that our walls can even hold longer than 20 years.
Thank you. Last question about the costs. What's the difference between the costs of your product and conventional products? Are there differences?
Thank you for the question. That's like probably the most important question when you have a sustainable technology. It's green, ecological and everything, but is it also cheap? I can say that our product is competitive in price compared to conventional products. This is due to many reasons. First of all, we use materials which are, for instance, the reed, which are more of a waste product right now in Austria. Second of all, in the whole lifetime, we have much less costs than conventional products because our wall does not need any maintenance and we don't produce any hazardous and also expensive waste at the end of the lifetime. So especially when looking at the whole lifetime costs, we can be competitive or even cheaper than conventional products on the market.
Thank you. Is there another question? Yeah.
There has been a lot of research regarding integrating photovoltaics into these noise protection walls. Did you have any research in that direction as well, or could you imagine integrating photovoltaic modules of any kind into these walls?
Yes, this is definitely a topic. It was also announced by politicians that we will do so in the strategy to integrate or to use these walls as a power plant, basically. As we are still a very young startup, we are currently now focusing on our technology to improve it step by step and access the market, basically. However, integrating solar panels inside the walls is already a topic. However, the problem is that these photovoltaic panels are not noise absorbing. So this does not adhere to standards needed on streets. So you could only, for instance, place the PV panels on the back of the wall, where mostly it's green or the sun does not really shine there, or on top. And for the on top option, technologies have already been developed here, which are independent of the used noise barrier wall, basically, because it's just set on top.
Thank you.
Yeah, there's another question.
A very interesting approach. Did you also think about introducing this technology into the cities, into facades in cities to reduce the city noise? The facade areas would be another dimension than what we have in noise cancelling in roadways.
Well, I will not tell too much, but yes, we are of course seeing the power of REIT and also the power that we can achieve here with sustainable materials. And we have already many ideas for many more innovations, not only in acoustics, but also for other building purposes in mind. Did I answer your question, or would you like to?
Could it, if I may add, be used also as a noise cover for heat pumps? Because that's a topic in cities often.
Yes, I heard of that topic too. We have not yet looked into that market. I don't know what the special norms say for this market segment, but in general, I would say yes, there's always a way.
Okay, great, because...
So thank you for the presentation, and very innovative product. Thank you.
Thank you very
so
much.
Let's go to our next speaker, Mr. Bernhard Reichel. He's the head of engineering from Slavonia Building Company. Very warm welcome. The floor is yours. Thank you.
Thank you very much. Yeah. Today we want to speak about... Presentation is also not working. Sorry. I'm the head of engineering for Slavonia. We are a family-owned company. We are a family-owned company based in Vienna, and our company started in 1893. So it's a company with a long tradition. We have at the moment 15 employees in Vienna, and we are mainly active in the headquarter in Austria, but we also have another quarter in Slovakia. Our company is producing many different topics, for example, the isoflame watering proofing membranes, the tunneled concrete protection, and wood and fire safety systems. But today, in the case of the GreenTech Days, we want to speak more about photovoltaic and green facades. We provide the SpeedyMax fixing system for ventilated rain screens and also for ceilings. To better understand what is the rain screen, we need to know a little bit more about how a classical rain screen cladding works like. So basically you have a cladding mounted before the insulation, and between the insulation and the cladding you have a air gap between 3 and 5 centimeters. So basically the air can ventilate behind the plates and is cooling also the insulation. And you also have additional benefits like, for example, rain protection, fire safety, and also noise reduction. To see what normal rain screen cladding looks like, I have put 2 examples which we have done in the past. Both are typical aluminum composite materials, but also in this case it's good to understand what are the optics possible. And especially when I talk more about then the green facades and the photovoltaic facades, you can have a good example of how the look can be like. The main advantages of our SpeedyMax subconstructor system is that we can produce our brackets in lengths from 60 till 900 millimeters. We have a pre-assembled thermostop and we can produce it in 3 different qualities, for example, aluminium, stainless steel and corrosion protective steel. And the main advantage is that we can mount the brackets in both directions, so you have just one product on your warehouse and on your stock and can build many different topics. When it comes to the photovoltaic facades, we have a lot of today's guest speakers here which are talking about these topics. Basically, when we talk about photovoltaic, many people think that those are the standard modules which we all know from the roof, which have the blue optics, but now it's possible to also print special decor optics and also many different colors. So as you can see, it's possible to have many fancy looks on the facade. I mean, the main advantage on the facade is that you have more yield in winter with the lower sun, and it's a perfect combination with the roof facade. Our basically fixing systems which are possible is, for example, with clamps for glass modules. We have a special back rail system which can be mounted for normal framed modules. And we also have a combined gluing system combined with the glass modules. Here you can see some examples of projects which we have done in the past. For example, this is a project based in Switzerland, which have been 161 PV modules installed on the facade with special decor optics. And also you can see the gray modules on the front of the house is also PV modules. And it produces the energy about 4.5 houses per year, based on the 4,000 household with around 4,000 kilowatt hours per year. That is also one of the biggest facades in Austria. Those are 8 buildings in a business park, which have been installed with photovoltaic facades. And in this time, it was combined with typical rain screen claddings. And the architect wanted to have it visible, that it's not hidden, and special optics. So he wanted to have it visible, that you can see those are the PV modules. And what is really interesting is that we can produce the energy for 98 family houses per year. So we have many unused areas in the business parks and so on. So we can use these areas, for example, to create energy on the facade. Another topic which we can do is we can renovate projects. This one is based in Liechtenstein. As you can see, it was an old concrete bunker, but with the PV modules on site on the facade, it can give them a new special look, and also additionally it can produce energy. Another thing which we believe will be the future are the green facades. We have together developed with the company Nature-Based the living panel systems. It's a pre-cultivated pad system which can be mounted on our facade systems. And the main thing is that it can provide cleaner air, and also it's a plug-and-play system which can be mounted. The problem is that in the cities we are building more and more buildings, and we reduce our green spaces in the city. So what happens? The cities are getting hotter and hotter, and this can be a way how we can reduce this. We have done some 3D simulations together with the Living Pass, and the simulations shows that we can save up till 8 degrees in the ambient for the rooms, and it also lowers the temperature outside to the other environments. Yeah. I will show just some example of how the system can work. You can see that we have basically an isolation system. Our SpeedyMax wall brackets mounted on it, there are the special cultivated pads on it. And in it there is also special rain sensors which measures the water inside of the facade, and also we have a remote maintenance which can detect errors, so on. So this would be also a perfect case for the future. So if you have requests, let us know and send us a request. Thank you very much.
Thank you. Some questions? Okay. Then thank you very much. And I will announce our last speaker. He will announce the BOTS Congress, which will take place tomorrow here at the Chamber of Commerce. I welcome Tobias Walton, and he will give us 5 minutes overview about the Congress starting tomorrow. Thank you.
Good morning again. Thank you, Mr. Chairman. Ladies and gentlemen, why do renovated buildings need good company? That's the theme of our Congress that starts tomorrow here in this building, on this premises, on this floor. And I want to give you some reasons to register lately to this Congress. Why do renovated buildings need good company? You could ask good company is something for people and not for buildings. Buildings have spaces and arrangements, but not company. But you will see that's not really true. Think of a traditional urban quarter. Buildings turn its facades to streets, or they may form a place, a courtyard. The formula is outside walls of a building are inside walls of public space. And public space is the place where good companies for buildings unfold. This habit of traditional town planning changed in the 20th century. During most of the 20th century, buildings typically keep distance at each other. They tend to be oriented to the sun, for example, but not necessarily to the streets. Their facades form a space of light, a space of air and ventilation, and in the first place, a space of admiration, of sight. A space that is neither public nor private. It's called semi-private, but it is not the best of both worlds. It's the opposite. It's not the best of both worlds. Yeah? It's the worst of both worlds. And it's our normal environment in the 20th century. The architectural separateness of modern buildings, though, is in a way an illusion. Why? In about the same historical moment when new buildings stopped forming public spaces, they became connected with technical networks of many kinds. Wastewater and drinking water made the start. Remember, small hotels announce fließendes Wasser, running water in their rooms. Then came gas. Have you seen, maybe in Vienna, old gas pipes or their remnants at the ceilings of rooms for lighting? Still not working, but there. So gas. Then later came electricity, even later telephone, and newly wiring for data transfer and before for television. Distant heating and even distant cooling came into many quarters. All those technical networks have in common they are operated by big centralized communal or commercial institutions. Inhabitants are being involved as customers, not as citizens. Now, in the 21st century, we enter the next stage, right now. Centralized networks get complemented with decentral, local networks for electricity and heating. Building owners or operators take advantage of the surfaces of their buildings, like we have heard a lot of today. They can use for electricity and hot water generation, rainwater retention, rooftop gardening, or leisure. Green facades will cool and decorate public or private, or the mentioned neither-nor spaces they are exposed to. And building owners take advantage of similar capacities and complementing demand profiles of neighboring buildings. How? Customers of centralized network providers start to act as citizens and entrepreneurs and negotiate contracts with each other in energy communities. For example, think of a server farm in Vienna delivering its waste heat to an hospital nearby for heating. Or think of Eeclo, the small town in Belgium that was reported these days to produce 130% of its electricity demand with wind turbines and PV, owned by the citizens of Eeclo. But it is not only about technical networks. Residents who care for their neighborhood and building owners and politicians who care for those residents will try to develop free space between buildings as habitable places, inviting for leisure and developing locations promising for all kinds of businesses. At ground floor level, for example, or of buildings or on rooftops. Here we are with renovated buildings and inhabitants in good company. All what I have said so far was about revitalizing the existing building stock. New buildings may be added here and there, but they ought to upgrade their neighborhood. So my advice or my appeal to building owners, good company is what you need to find and what you need to provide in order to revitalize your old building. So much for Bouts Congress 2022. Bouts Congresses have come a long way. This year is the 19th event in the series and the second time we do it together with Advantage Austria. Each year from 2004, we have tried to accompany a vivid Austrian and international scene of architects, developers, scholars, students, consultants, engineers, building product manufacturers, and representatives of authorities in charge of sustainability policies and programs. All have been invited and welcomed year after year to present their newest achievements and their proved solutions. Of course, it was not always about company. Building materials ecology, circular economy, energy efficiency of building envelopes, innovative building services have been topics of interest all the years. Yes. Bouts is organized by IBO, the Austrian Institute for Healthy and Ecological Building, founded 41 years ago, engaged in research and dissemination, and supported by its consulting company IBO GmbH, almost the same name, which has a lot of activities, the IBO GmbH. Bouts Congresses are organized with consultancy from a powerful panel of experts from Technical University of Vienna. Karin Stildov is present. Danube University of Krems, University of Natural Resources and Life Sciences in Vienna, University of Applied Sciences Technikum, Vienna, and then very interesting, the ACR network of cooperative research of SMEs, and EcoPlus, the business agency of Lower Austria. So I have a panel of 17 people, very bright people who can give me any advice I need. Speaking of good company and support, I wish to thank the Federal Ministry of Climate Action, our public sponsor, and then Stein and Ceramic, and now it gets complicated in English, the Austrian Association for Building Materials and Ceramic Industries, together with the Central Industrial Construction Products Manufacturers Association, short ZIB. EcoPlus the business agency of Lower Austria again, and WKÖ Austria, a building product manufacturer in Finland with an Austrian base, and Baubook, an Austrian online database for construction products where IBO is involved. And I want to give my thanks to the cooperation partners Advantage Austria and Go International of Austrian Economic Chambers, now for the second time that we work together, but in our panels they were for many years, and Business Finland. Today is GreenTech Day. Tomorrow and the day after tomorrow is Bouts Congress. You guess it, this adjacency is planned on purpose. We want to make it easy for you and suggestive to take part in both events. Be welcome at Bouts. Thank you.
Thank you very much. Thank you very much. So we hope some of our visitors in the live stream will meet us next year here in Vienna. Ladies and gentlemen, today we have heard a lot of ideas, innovations and products which can help us to hold our environment clean and to achieve the goals concerning European Green Deal. Let's work together to face these goals in the future. We hope to see you next year here in Vienna, and we thank you for listening. Thank you. Bye-bye. Thank you.
Das Einzige, das geht? Ja. Alle anderen gehen nicht? Ja. Was, alle anderen Mikrofone gehen nicht? Ja. Zu langbauriger. Hallo, hallo, hallo. Hallo, hallo. Achso. So, jetzt. Da war PFL gedrückt. So. Jetzt geht's. Okay. So, jetzt. Das ist wahrscheinlich noch der Monitor, beeinflusst das wahrscheinlich.
Welcome to the second breakout session at the GreenTech Days. This is Bernhard Puttinger from the GreenTech cluster, and I'm representing also Hydrogen Austria, the cluster, and Magdalena Lindl, which is also here in the room. It's an honor to welcome you all here in the room, as well as back home or in the office in front of the monitors. We are now looking towards the hydrogen future and which solutions, which research is going on in Austria. We'll have first introduction from my point of view concerning the research map that you would like to see of what is going on in Austria. We then have from the High Center, the Hydrogen Center Austria, a presentation on the hydrogen aspects and research that is going on there. We're following then with Dominik Mittermeier. He will join us online from Fronius. Fronius, well known as technology leader in the fields of solar thermal, in solar as well as hydrogen. After that, we are closing with two other speakers from AVL List, Richard Schaupal, as well as from Worthington Industries with Radina Nunic. I'm looking forward for interaction here in the room. I'm really curious about your questions, how to develop a joint future that is driven also by green hydrogen. Green hydrogen, it's a research topic still, but it's also already out there in the market. Let me start, which is quite unusual that the facilitator is also trying to start with the first presentation. What we have done is we researched what's going on in Austria, who is doing what in terms of hydrogen research, who has which facilities, and we made it available for you to download it afterwards to access these contacts online. Next slide, please, but I think I can do it, yes. Austria is in the European Union Eco-Innovation Index regarded as eco-innovation leader. It's a top 3 country, and it's number 1 together with Estonia and Finland in terms of green tech turnover. So this is really a hotspot. I already mentioned this in the morning session. We see that especially in the south of Austria, in what is also called the GreenTech Valley, that there is a lot of concentration of businesses and some global rankings from US venture CleanTech Group, but also from others. The Global CleanTech Director see this hotspot here in Austria as the global number 1. Make your own choice and stay tuned. I'm the manager of the GreenTech cluster in the GreenTech Valley, and you see a lot of solutions, and in the core you might also see hydrogen, green hydrogen for several applications for mobility as well as energy systems as well as industrial applications. One last word to the cluster organization. We are 10 industry experienced employees, 280 companies in the meantime, and we are there since 2005 and also lead the benchmark in terms of cluster management excellence on a global scale. Our mission acronym is 100, meaning 1 Earth, 0 carbon, 0 waste, and green hydrogen is also key towards this goal, not only towards green zero carbon, but also 0 waste. We are used to do radars, so showing trends and technology opportunities for companies, just like here with green hydrogen. But now coming to the point, what is the H2 research in Austria like? Where are the academic and non-academic research institutions? Where are they located? How big are they? Are they rather into systems research or into single technology research? The bigger, the more employees, the greener, the more technology research is going on. And we also did a research, how is Austria positioning itself in Europe's research landscape. When looking there, we see that of course you have to look at the Forschungszentrum Jülich, which seems from our perspective with the most employees, then probably followed in Norway with Sintef, and then we see already the Graz University of Technology campus in 3rd place, followed by other institutions in Germany as well as France Grenoble. May I introduce you only a few of these in totally 18 institutions with more than 300 specialized researchers in green hydrogen here in Austria. Then we look first at the Graz University of Technology. You have more infos. I won't go through it. You will have the opportunity to download the slides right away at the end of my presentation, but you get it also from the organizers. So we have here Institute for Chemical Engineering for low temperature fuel cells, test stands, but also internal combustion engines based on hydrogen with test stands and fuel cells, but also in the truck area. And the Institute of Thermal Engineering with several topics, but also with high temperature fuel cells. When moving on to the High Center, you will hear a lot of information later on. The Hydrogen Center Austria is the most specialized institute in Austria with focus on green hydrogen in all aspects, mobility, industry, but also grid stabilization, and it's a lot of test stands and laboratories. And last not least, at the campus of Graz University of Technology, we see the Large Engine Competence Center, which is focusing mainly on ships and how to get 97% of CO2 emissions down in global hydrogen in global ship industry with the help of green hydrogen. They have a lot of laboratory and test facility, really the big ones, together with INEO in Jenbach, for example. And this campus is facing a lot of investment upcoming, also new infrastructure that you, as an industrial partner from Austria or abroad, can utilize for joint projects. Next, I come to University of Leoben. They are specialized in terms of hydrogen and carbon research center, so the combination of how to utilize carbon and to use it with green hydrogen for new biopolymers, for other aspects of renewable energy sources that are a synthetic source. And you see also a circle that is deeply green, so meaning a lot of laboratories and testing facilities there for you as partner. We're coming to the Vienna University of Technology. They are focusing in different aspects, especially also in green fuels from biogenic waste. I think quite a promising source as it is waste, and that was I mentioned before. We see that even waste can be a good source for green hydrogen. Besides others, materials engineering, chemical processes, and there's a strong energy economics groups, besides some laboratories and test facilities. So these were only 5 out of 18 institutions. Please find more in the whole landscape that you can download for free in German and English language. You find here short links to the hydrogen research map, but also if you're interested in Green Deal, in other research aspects, or in technologies from the GreenTech Valley, you've got 4 QR codes. You don't have to scan those, because download this presentation now by scanning this QR code, and you will have more infos just at your fingertip. With that, I switch from the role of a presenter to the facilitator once again, and I'm really happy to have with Anna Macherhammer a real expert in terms of hydrogen. I'm really looking forward to your presentation. I cleaned the podium for you, and the floor is yours for the next 20 minutes. What is High Center doing? What are the aspects we can discuss afterwards?
Thank you very much. Good afternoon, ladies and gentlemen. My name is Marie Macherhammer. I am an area manager at the High Center in Graz, and I'm very happy to present today to you current developments and examples of the hydrogen technology. First, I'd like to start with a couple of words about the High Center itself. So the Hydrogen Center Austria is an extra-university public research organization at the campus of the Graz University of Technology, who is also our major shareholder. We have been working in the field of hydrogen, and therein in all the technology fields along the value chain, for about 17 years now, and today we are more than 55 researchers from different fields like mechanical, electrical and process engineering, but also physics and chemistry. As already mentioned, we are covering all fields of hydrogen. That's also why I'd like to show just a short slide about our organizational structure. We are divided in 4 areas. The first one is electrochemical technologies. This is my area, where we are working on all technologies of electrolysis from cell to stack to system, as well as electrochemical compression and alternative production methods. The second area, infrastructure technologies, is covering topics like purification, compression, storage of hydrogen and distribution, as well as optimizing configuration of hydrogen infrastructure. Our third area is about measuring and test systems. We do have quite an extensive testing infrastructure. I'll have a couple of pictures on the next slide. But we are also working on the development of methods for testing and special material investigations, for example, for hydrogen storage. And the fourth and last area is about mobility technologies, and this covers fuel cell propulsion systems from land to water and air, as well as on-board hydrogen storage. We try to combine research and development from a design perspective, as well as with modeling and simulation models, and then validate these models as well as the design in measurement and testing. What you can see here is examples of our infrastructure. So I'll start with 2 refueling stations. We can refuel 350 and 700 bar vehicles, which is interesting for bus and trucks, as well as cars, passenger cars. Furthermore, we do have a high pressure test stand to test components up to 1000 bar, which you need if you want to introduce a hydrogen refueling infrastructure, or even if you want to test storage systems. Additionally, 2 test cells for components and system testing or subsystem testing. Furthermore, a fuel cell system test bench where you can test fuel cell systems up to 160 kilowatts, also in a climatic chamber from -40 to +85 degrees. We have several electrolysis test benches from cell to stack and a gas analysis laboratory to check quality of hydrogen, for example, also refueled at the refueling stations. But now let me start with the hydrogen economy and how we see it. The market forecast of the Hydrogen Council says that the demand for hydrogen will increase about tenfold up to 2050, within the years up to 2050. So from 8 exajoule to 78 exajoule. This means that the demand will be distributed over several industry fields, but also transportation, building heat and power, new feedstocks, and it has the potential to replace conventional fossil fuels about 20 to 30% as an energy source. To ramp up this industry, we do need R&D as a precondition for the proof of concept, and it always takes several years to introduce new products, new developments into the market, and then have it available for the industry. And how do we implement the hydrogen? How do we see, what is our vision of the green hydrogen economy? So if you want to implement renewable energy sources like water, solar and wind power, you receive green electricity and you can either store it or distribute it via the grid, and then use it directly, for example, for battery electric vehicles or in buildings or in industry. But if you want to switch to 100% renewable energy sources to produce electricity, you need some kind of storage because of the difference between supply and demand. And that's where hydrogen comes in, and you can produce with the excessive excessive electricity, you do not need at the moment via electrolysis hydrogen. The hydrogen can then be either stored in gas caverns or as gaseous or liquid hydrogen, or distributed via pipelines, and then again either used in fuel cell vehicles or in industry as feedstock, or be electrified, re-electrified via fuel cells. I'll start with the production of green hydrogen. There are several technologies already available, like alkaline electrolysis and proton exchange membrane electrolysis, for example. But there are also new technologies like anion exchange membranes, which have the potential for cost reduction. Then we do have high temperature electrolysis, which will be more discussed in detail by Richard Schaupo afterwards. And I'd also like to mention the European Union plan to install 6 gigawatt by 2024, which is a very ambitious goal of electrolysis to produce green hydrogen. Additionally, there is ongoing research on pyrolysis and gasification of biomethane. And we're also looking in alternative technologies like photolysis and photoelectrolysis. Couple of words about that a little bit later on. Here is quite an extensive sheet about the different types of electrolysis. Just a couple of key points I'd like to share with you. When you're looking at the proton exchange membrane, it's important that you know that the electrolyte is acidic but solid. Therefore, the hydrogen protons travel across the membrane, in comparison to the anion exchange membrane, where you also have a solid electrolyte, but an alkaline one. That's why the hydroxide ions travel. These are both, as well as the conventional alkaline electrolysis, where you do have a liquid alkaline electrolyte, low temperature electrolysis technologies. And in comparison to the high temperature solid oxide electrolyzer cells, which do have a solid ceramic membrane where O2 minus ions are transported. These temperatures can go up till 1000 degrees Celsius. I'd like just to put the focus point on two research projects we are actually ongoing right now at HyCenter. One is the project Recyclize. It's a European project, and the goal is to reduce the critical raw materials needed for catalysis within the proton exchange membrane electrolysis on one hand, and on the other hand to recycle the ones used. Therefore, we look at the entire value chain from the manufacturing of catalysis until the end of life, and try to recycle and reintroduce the catalyst materials in the electrolyzer system. This leads towards a circular economy where the CRM will be recovered and regenerated. The next project is together with Fronius, where Dominik Mittermeier will also give a presentation later on their work on hydrogen, as mentioned. In this specific project, we're working on industrializing materials for PEM fuel cell and electrolysis, and this should lead to a system where you can at home install a system of electrolyzers to produce hydrogen and then re-electrify it via the fuel cell to be more autonomous. The goal is to decrease costs and increase efficiency by combining these two systems. Another project, another research area, which is still very, very actual and very interesting throughout the community, is high pressure electrolysis. Because as mentioned, especially for vehicles, you need hydrogen at higher pressures. Therefore, you need compression to get it up to 450, 700, 850 bar. And this compression needs energy, and therefore throughout the whole system decreases overall efficiency. The possibility to produce high hydrogen at a higher output pressure leads to then probably also, like we had a project where it was able to produce hydrogen up to 150 bar. But there are several drawbacks, because due to the higher output pressure at 55 bar of the hydrogen, you have higher back diffusion, therefore less efficiency over the all systems. What you can see here on the right hand side, within the project Wind to Hydrogen, there was also a simulation model developed where to forecast the different results we'll receive with the experimental data. And this shows that the simulation results and the experimental data quite nicely align. Therefore, the simulation tool itself can help to decrease necessary experiments and therefore facilitate projects by reducing costs and just forecast different results. As mentioned, we are also looking at photocatalytic water splitting, where photons can be directly used to produce hydrogen by separating water into hydrogen and oxygen. Solar water splitting, there are 3 different approaches we're looking at right now. So under number A, you can find photovoltaic electrolysis, where you actually combine a photovoltaic cell with an electrolyzer, either separately, which is called here a wired system, or we are a monolithic system where you put everything together and have like a zero gap arrangement. The second approach, number B, would be photoelectrochemical cells, where you have a photoelectrode or a photoelectrode approach, where the photon splitting and the redox reaction, the photoabsorption happen in one step. And the photocatalysis is the most simplified approach, where you have just catalysis powdered particle, one for hydrogen evolution, one for the oxygen revolution, or put on a substrate and there you have a photocatalyst film. As you can see, these are quite proof of concept approaches, so there are several questions still to be answered, like how do you design a reactor for this, how do you upscale this, how you move on from here. Moving on from production to storage and distribution, compressed gas storage is state of the art and has been developed for several decades, of course. You also can store hydrogen in its liquid form at minus 253 degrees Celsius. There is also a lot of research ongoing in the fields of underground hydrogen storage. I was in Canada last week, and also there a lot is going on, try to store hydrogen in salt caverns. And alternatives like liquid organic hydrogen carriers or metal hydride storages are now the focus in storage areas of R&D. The distribution can be done via gaseous hydrogen or liquid hydrogen trailers. Then a huge project is set up, which is called the European Hydrogen Backbone, where pipelines will be set along across Europe only for hydrogen, pure hydrogen pipelines. And I think everybody is also aware of ships transporting liquid hydrogen or hydrogen in other form of storage across the Atlantic and Pacific Ocean. This slide should show you just concerning metal hydride storage systems. There's quite a lot going on. There are a lot of different materials. There are a lot of different combinations of material, and they're all in an early research state. But they are quite interesting because it's a very safe application. The only thing you have to manage is thermal management, because you need energy to store it in the metal hydride and then get it out again. Additionally, as already mentioned, hydrogen at the higher pressure is very preferable depending on the application you use it for. But we are also looking into electrochemical compression. This would function like electrochemical pump, so like a cell itself. It just moves the hydrogen towards the membrane and then increases the pressure on the outside. The advantage is that you don't have any moving parts, you don't have any noise, And if your hydrogen is not as pure as you want it, it also leads to a purification. In industry, I think most of you are aware that hydrogen has been a commodity for decades. It's needed in several industry fields. Right now, we do have the challenge to transform the gray hydrogen towards green hydrogen. And there's also research going on in innovative processes, including, for example, green hydrogen for decarbonization in steel manufacturing, or as a feedstock in different other applications. Another field would be high temperature processes like heat exchangers and burners, for example. There I'd like to point out one industry project which combines two already ongoing projects, H2 Pioneer and Rehype. In this project, hydrogen is needed for the manufacturing of semiconductors. Right now the hydrogen is gray hydrogen, so the first step would be to transform it to green hydrogen. And then the hydrogen is needed as a very high purification stage, which means 8.0. A colleague of mine has a very nice comparison. What does mean 8.0? If you imagine a grain of rice, that would be 1 grain of rice on 6.5 tons. Like this would be the impurity you would allow in an 8.0 purification. Then the hydrogen is used in the epitaxy process. Up until now, it wasn't used any further, but the idea is to then purify it again to 5.0, so a little bit lower, but this is what needed if you use it in fuel cell vehicles, for example, in buses. And this is the goal, to then reuse this hydrogen as a fuel in buses in Carinthia. Hydrogen in fuel cells, I think the discussion about is hydrogen really the solution for mobile applications is a big one. Here I'd like to show you what has been done so far. There are fuel cells in all these vehicles, so everything was tried and set to be fueled with hydrogen. I don't want to go into detail about the discussion. We can do that afterwards in the break if you're interested. Just one comment. We compared heavy-duty applications. So what I think and what we think is that fuel cells might be interesting for heavy-duty applications, because if you compare the powertrain and storage, it takes much less weight as well as volume compared to a battery electric vehicle. Therefore, yes, the efficiency is higher of a battery electric vehicle, but if you need twice the trucks to transport your product somewhere, you might rethink your application. And which is also still true is the refueling or charging duration. You can fill up a truck, depending on the amount, of course, but within 20 minutes with hydrogen. Just to point out one project which has been almost finished, not yet. We have been working on the development of a fuel cell system which would be implemented into a heavy-duty truck, about 40 tons. And our partner, AVL, has developed this fuel cell system, which is a modular approach. So you can stack like several different systems together to reach higher power, for example. One module is about 156 kilowatts. For the 40 ton, you would need like two modules, so that you have more than 300 kilowatt of power. And what you can see here is the system itself on our testbed at HyCenter, where we checked for performance, reliability, free startup, because it has to be working at minus 30, minus 40, minus 20 degrees. And it has to bring the power to the wheel in a certain amount of time. And this is my last slide, what we are also part of, and we'd like to point out that there is an energy model region hydrogen in Austria. You can see all the partners on the right side, and the goal of this organization is to introduce a hydrogen-based energy system in combination with renewable energy sources for all sectors of the economy, which mean that you implement the entire value chain and all, as well as research partners and industry partners to create this kind of hydrogen region, hydrogen valley. Thank you very much for your attention, and I think we're just moving on.
Thank you for introduction. Also, the energy model region hydrogen. May you stay for a short Q&A? And also introducing the session partner, Viva PNG, the energy model region. I think it was a quite comprehensive, despite very technologically deep overview on what HiCenter is doing. I would like to do it just like direct Q&A, as we are in a very tight schedule. So therefore, your question from the audience, I take and come to you. One, I'd like to start beforehand. We have a lot of international partners out there in front of the monitors. How can they now cooperate with the Hydrogen Center Austria?
Well, I would say that there are different possibilities. On one hand, we are part of a couple of international and international research projects, either financed by the European Union or on different schematics, because we're also part of Hydrogen Europe Research, which is the organization responsible for hydrogen technologies across Europe. But on the other hand, we are also very open to direct cooperations, specifically from industry, if there are specific questions you would like to be answered within certain technologies field. I'd love to take any requests.
Okay, perfect. One last question, if there is none from the audience. How has the war in Ukraine brought new contacts to you, whether hydrogen can be a solution to get out of Russian gas?
Well, to be really honest with you, I think it even started before with the awareness of our climate change. Industry started to look beyond their limits, beyond their borders, and came what way can we do in our specific industry field with hydrogen. But as what we can see after the first shock of the war, people are looking more towards alternatives in every field. So
industrial application research will be in the strong uprise.
Yes.
Thank you. Marie Macher-Hammer, Area Manager from HiCenter in Graz. We are now moving on from science, from research to industrial research that is provided by Dominik Mittermeier at Fronius International. He's the responsible for hydrogen sales. Probably you know Fronius from the Sol Hub, a green hydrogen filling station system, also mentioned on one of the slides from Marie. And Dominik Mittermeier will share the newest developments in terms of hydrogen. Dominik, can you hear us? You're connected with us online. I can hear you somehow, but we still think working on the sound. Could you say something again?
Hello?
Now it's
Can you
working.
hear me?
Yes, perfect.
Yeah, good.
Perfect. So I saw also some slides from Sol Hub. I'm looking forward to the next 10 minutes. The floor is yours. Dominik, thank you so much.
Thank you very much for the introduction and for the invitation to this great event. My name is Dominik Mittermeier, and I'm looking forward to presenting the Sol Hub. First, I'd like to start with worldwide more than 6,000 employees, close to 1 billion in turnover, and we've got like 37 international Fronius subsidiaries, and also more than 60 countries with sales departments or representatives, basically. Yeah, as you can see, of course, we are also investing a lot of money into innovation, and this.
Dominic, I'm very sorry. We tried to figure it out. The sound is quite poor. Can you improve something? Can you, for example, turn off the camera so that we have more bandwidth for your slides and the audio?
Of course, I'll try.
And it sounds good for the moment, but it's not very stable so far.
Sorry for that. Try again.
Yes, so I think you might proceed. Let's try it.
Okay, please let me know if it doesn't work.
Sounds
somehow.
way better so far. I tell you otherwise. Thank you.
So here we are again. So I'll continue with the presentation of the business units. As I mentioned before, we were founded 76 years ago with the Perfect Charging business unit, where we are offering solutions for intralogistics, where we are manufacturing turnkey solutions, basically for charging solutions for forklifts and so on. And we have the Perfect Welding business unit, which is our second youngest business unit, where we are offering products in the welding process or for the welding process, and where we are also strong in the automotive sector with robotics and automation systems, also turnkey automation systems. Last but not least, I want to introduce you to the solar energy business unit, where we are, I'd say, famous for our inverters, high quality, high efficiency products, and there is also our hydrogen department situated, and more on that later, of course. First, I'd like to introduce you to our vision in the solar energy business unit, and the vision is called 24 Hours of Sun. And what's the purpose of our vision, or what does it describe? We want to generate energy from renewable energy sources, and we want to transport it, store it in an efficient way, and make it consumable at the prosumers with our products and solutions. As you can see in this picture, it's also quite prominently displaying our hydrogen applications with the Soul Hub. We are mainly focusing on producing locally green hydrogen for emission-free transport, and also in sort of a hub for energy management for seasonal storage. Yeah, we've got 20 years of expertise, and I want to show you a few of our projects we were already realizing, also as Heisent already mentioned, together with Heisent and various other partners. We started like 20 years ago with the production of a fuel cell, a mobile fuel cell for intralogistics, and also in parallel with the infrastructure for refueling it. Of course, we also focused on products for the residential sector. So a combination of electrolysis, fuel cell, waste heat usage, for example, in the energy cell that we introduced in 2010. Projects like the solar to hydrogen project, the wind to hydrogen project, and so on. And since 2018, we are offering our solar portfolio. A portfolio which covers a lot of different applications for green hydrogen. And here are a few other references that we already implemented. For example, the HySnow project together with Heisent, the Rotax, and so on. And the Solar Hub in Steinhaus at our Competence Center, where we have realized a 700-bar refueling station with local production of green hydrogen. Yeah, the Fronius Solar Hub is a turnkey solution for the local generation, storage, and use of green hydrogen. We want to to have our products for mainly in the sustainable mobility sector and also in energy solutions, of course, for towns, municipalities, commercial and the industrial sector. We offering alternatives to fossil fuels with the green hydrogen, and we are implementing seasonal energy storages for shifting surplus energy from renewables from, for example, when I'm taking PV into account from summer to winter. We're offering turnkey solutions as a one-stop shop. So we're customizing those plants regarding in regards to the requirements. We're setting them up, we're maintaining them, and we're managing them, and we are scalable and multipliable. You can see the solar portfolio and the main parts are basically a full-fledged solar hub, as it can be seen, for example, in Steinhaus. I'll start with the hydrogen production. We have containerized solutions for our PEM electrolyzers, where we are offering H2 quality up to 5.0. We can supply daily production values starting at 48 kilograms up to 900 kilograms per container. We can also scale in between 48 and 109 container within a container. And we have respectively, we have electrolyzer powers of 0.50 megawatt up to 2 megawatt in such containers, which can of course also be multiplied up to, I'd say, the very low two-digit megawatt area. And of course, we're also implementing waste heat usage, oxygen usage when it makes sense from an economical point of view. As you can see in here, we have also integrated our electrical equipment, the controls, technology, and also fuel cells in the electrolysis containers, also dependent, of course, on the use case. We have a dedicated container for hydrogen compression, basically in 2 steps or up to 2 steps. We are compressing the 30 bars from the PEM electrolyzer up to 450 bar and also up to 900 bar when, for example, it's needed to fulfill or to refuel 700 bar passenger cars or other vehicles that need to be refueled with 700 bar. The hydrogen storage is also depending, of course, on the use case. When we have to refuel buses in the public transport, for example, with 350 bar, we're implementing 450 bar middle pressure storages up to 900 bars, as I mentioned before, but also low pressure systems, 30 bars, 50 bars. So cheap storage, for example, for the seasonal storage use cases. And of course, we are offering the dispensers that are needed for refueling and also pre-cooling equipment when it's needed to have even a quicker refueling time than already mentioned, up to the 20 minutes for a bus, for example. As you can see in here, we are not only focusing on hardware and something like that, we are really a one-stop shop. We are also developing the controls and the software for the solar, and we are offering our services and support for those systems. We have a worldwide support network, a service network for hydrogen solutions. And what's also very important, we have direct interfaces to green electricity, to energy production, basically. We can also offer PV power plants in accordance to our solar systems. We can take care of green electricity with our partners from the energy providing sector and so on. And we also are developing some of those systems, as can be seen with our Fronius emblems on those hardware parts. And the most important thing that we'd like to achieve with our solar is, of course, to generate very low TCO for the customer. So that's the main goal, of course, and this can be achieved, of course, with low electricity prices, high efficiencies, the usage of waste heat, the usage of oxygen, and so on. As you can see on this slide, here we have the path to your solar, basically, and what it needs to implement the solar station, hydrogen infrastructure on site. So it always starts with getting to know what are the requirements of the customer. That's the most important part of the developing of those concepts, of course. And those concepts, those rough concepts for the hydrogen infrastructure are the foundation for non-binding offers. And of course, what's the second part when we're offering those systems is a TCO calculation. When we're proceeding with the project, we are offering detailed engineering services for achieving those or for gaining those permits that are needed, for example, from a constructional point of view, building permits and so on, and also commercial permits. And we are also supporting the applications for subsidies. And in the end, we are offering a binding quote for the system. Afterwards, when we agreed on with the prosumer, with the customer, we are realizing the project itself. So it starts with the production in Steinhaus, close to Wels in Upper Austria. We are finalizing those permits with the customer. We're setting the system up. We're implementing it on site. Have a certain time span, of course, for commissioning, training, and handover. And in the end, in the operational phase, we are also closely working together with the customer on operational strategies for its dedicated applications and so on, and also, of course, with offering service and maintenance for him. Here's a short overview about Capex for hydrogen refueling station with 350 bar with on-site electrolysis up to 2 megawatts in this case. And what's more important than, of course, the Capex are the prices for the kilogram of hydrogen. And here I'd like to explain to you what's the biggest leverage for the systems. And what we've seen in all of those economical calculations is that electricity has a very huge impact, of course, on the TCOs. Capex are also important with roughly 14% for service and maintenance. Insurance is already calculated in, and so on. But as you can see in this share, electricity is very important. It's important to have cheap green energy for on-site electrolysis. And to support generating green energy on-site, we also offering simulation tools, for example, for hydrogen infrastructure in combination with PV. As you can see in here, we are working on optimizing self-sufficiency levels for the customer. For example, due to simulations where we are increasing electrolysis power, where we are increasing storages, and where we are basically simulating the most economical hydrogen infrastructure in combination with energy generation for the customer. So this is one of our biggest USPs, I'd say, in this sector. We are really one-stop shop. We know what's needed for cheap electricity prices, and also, of course, what lowers those TCOs for hydrogen. I'd like to close with a few references of our systems. Here you can see, for example, the 700 bar HRS, and also a development platform that we've implemented in Steinhaus in Upper Austria at our Competence Center. We're producing locally green hydrogen with PEM electrolysis, 700 bar refueling in the first step. We are pre-prepared to also offer 350 bar in the future, and we can scale up to roughly 200 kilograms per day, which is quite sufficient for our fleet, of course. And a customer project in Lower Austria, where we are implementing a hydrogen infrastructure, the Sun Group, which is capable of producing up to 100 kilograms of hydrogen per day, where we are supplying the internal H2 feed with green hydrogen, where we are storing a certain amount of hydrogen for backup power supply up to 50 hours, with 1.5 megawatt PV system already mounted on the roof, and it's ready for operation in July 2022, so not too far away. Will be very, very interesting, very nice project, let's say. So thank you very much for today's speech, for your interest in our systems, and I'm looking forward to your questions. Thank you again.
Thank you, Dominic. I hope you heard the applause, and if you stop sharing, probably can have you now your camera and that shall work. For some questions from the audience, are there some questions from the audience? I'm of course curious, which market niches do you look at where to start first? You produce electricity, you produce heat, and you also produce oxygen. Which customer segments do you see should be the first movers moving into Sol Hub?
Yeah, thank you for the question. So mainly the public transport, of course, especially with those fundings from EU level, where it also can make sense, of course, to implement the waste heat into heat sinks that are on site, of course, and where we can also see a very strong draw in the moment also for substituting basically methane, not only from the grid, but also for really feeding like up to 10%, for example, into heating purposes that are mainly fueled by fossil fuels like methane and so on. So on the one hand, public transport, a little bit later, lorries, of course, and everywhere where it needs to substitute fossil fuels, basically.
Thank you so much. Last question from my side: when will be there a fourth area of business at Fronius being called hydrogen?
Very good question, but I'm not sure if I'm the right one to answer it. But hopefully soon, hopefully as big as the already implemented business units. So I'm looking forward to it.
Thank you, Dominic. The applause is yours. Thank you. Time is running, so we're moving on. We are coming now to Austria's company with the most employees, I think, in hydrogen business, from AVL List, world's largest independent company for the development of simulation and testing of powertrain systems. And Richard Schaupal is a project manager R&D for hydrogen and fuel cells. And I was very impressed by the broad scope of technologies you are working on, be it high temperature electrolysis, be it e-fuels, be it low cost electrolyser technologies. I'm looking forward to the selection from today. Thank you so much.
Yeah, thank you very much. Yeah, thank you, Mr. Chairman, for your very kind introduction. It's a pleasure for me today to give a brief overview of what AVL is doing in this area. So I'm very happy today to see almost a full house here. So it's good to be back somehow to the real world. Let me start. Let's try this. Perfect. Good. Basically, AVL is the largest private-owned engineering company in the world, with the headquarters in Austria. So it's privately owned by Professor List, and AVL might be more known from the automotive industry. So basically everything what has wheels on it, but we are also doing other stuff, and this I would like to present today. Basically, we started around 20 years ago within the fuel cell business, and basically we grown since then a lot. So basically we started with a couple of people. So I'm lucky I was one of them. And now we are more than 500 engineers worldwide, basically headquartered in Graz, where we do the system engineering. And we have a really big affiliate in Vancouver, in Canada. And we have a big test center in Kecskemét in Hungary. And there we are also very, very active in various fields. And of course, we have a large global sales support with a lot of local supporters, for example, in UK and Japan. Following that, basically, we have so we're very active in 3 different pillars. So from the left-hand side, so we're starting with the mobility sector, where we are active in the PEM, field developments, stack development, cell development, and integrating those into systems and integrate this in different applications. In the middle, we're also active in power generation, so with very highly efficient power generation with the high temperature fuel cell. And last but not least, it's my talk today. It's about hydrogen production, so very high efficient hydrogen production with a high temperature electrolyzer as its key technologies. And I also want to talk about a bit about power to X and e-fuels. So hydrogen production. So basically, as my previous speaker Marie Macherhammer very beautifully explained, that this high temperature electrolysis has the potential for the most efficient way to produce hydrogen or green hydrogen out of renewable electricity, and this is caused by the high operational temperature. This is why less renewable energy is needed. Overall, 80% efficiency is possible, so we have already demonstrated it with our demonstration systems. And the way we did it is we use a lot of waste heat. So basically we have here about 800 degrees, and we use the waste heat to vaporize the water inside, and therefore 80% can be reached. So that's basically our state of the art. And what's the beauty of this system is that it can be very highly integrated into the industry. So for example, in refineries or very high CO2 intense industry fields like steel or cement, for example, where you can have heat sources or steam sources available already. And here you can reach even higher efficiencies with more than 90% in hydrogen production, which is very mandatory in this field to be very efficient here in Europe, and this is why I will tell you later on. Important, of course, is cost. So this the hydrogen production is very a cost-driven business. Of course, it's mainly driven by the electricity price of the renewable energy generated or produced, and of course by the efficiency of the electrolyzer, and to reach very let's say good price ranges for 1 kilogram hydrogen. It's important to have a system or an electrolyzer system with a very low operational cost, and this is where we see the highest potential for the lowest hydrogen fuel price on the end with the high temperature electrolysis. Basically, these values, of course, are calculated assuming the SOEC or the high temperature electrolysis already industrialized, which is probably done in the next 5 years. Now, 2 references. So basically, we are developing with our partner Ceres Power a 1 megawatt electrolyzer container system, a modular upscale solution, where basically we reach already 80 to 90% efficiencies in hydrogen production. This containerized solution will be deployed end of this year with a capacity about 1 ton hydrogen produced daily. One important thing to mention is that AVL is not an industrialization partner, so basically we are developing solutions for our customers, and later on Ceres is our customer and will industrialize the system. We are also active now in this very important IPSAI hydrogen initiative, where our goal is to establish a whole hydrogen electrolyzer value chain in Austria. Together with our partner Christoph, we have started this initiative to industrialize a 1 megawatt high temperature electrolysis unit, which will be later then industrialized by our partner Christoph Industries with a capacity of about 100 megawatt yearly starting 27. High temperature electrolysis and e-fuel production. It's a very, let's say, good way to couple the high temperature electrolysis with a downstream synthesis. This could be Fischer-Tropsch or whatever, because the coupling of a downstream synthesis with a very exothermic reaction, on the other hand, the excess heat can be used from the synthetic in the SOC system can also increase the overall total efficiency of the total system tremendously. So we can produce here, for example, with more than 55%, let's say a syncrude. So it's a mixture of diesel, waxes, and naphtha, which then can be further upgraded in a refinery, for example, to e-fuels or synthetic aviation fuel. Yeah? Basically, we are demonstrating now a 200 kilowatt plant with a yearly production of about 90,000 liters. Late 22 this year, the project will start. The demonstrator will be placed at AVL at the headquarters in Graz, where we basically have this containerized solution then built up, commissioned, and running for 2 years. And due to the high efficiency, low cost or a lower cost compared to state-of-the-art can be demonstrated with this high temperature electrolysis coupled with the synthesis. So in total, more than 20 to 30% cost reduction is possible with this technology. Good, this is my last slide. I want just to emphasize some key messages from today. So high temperature electrolysis, SOEC, has the highest energy efficiency of all electrolyzer technologies, but still is in the development phase for the next year. And then the deployment phase 27 will start. Based on this high temperature electrolysis process, hydrogen can be produced from 90% if there is an external heat source available or steam source available, 80% out of liquid water. Coupling of this high temperature electrolysis with a downstream synthesis can tremendously increase the e-fuel production efficiency. And last but not least, renewable energy basically will be the main path to decarbonization, of course, and of course hydrogen and all these derivatives have to be complemented and is needed in future. Thank you very much.
Thank you very much, Richard Schaupal. I think it was I promise not too much. Great area, great work you do.
Thank you.
More than 500 engineers only in hydrogen business. I think this is really a message. Any questions from the audience? I've got one or two I'd like to ask beforehand. You said the cost reduction of SOEC systems is key. What potential do you see when you gave us a 5 years horizon towards 27?
Yeah. So now all initiatives are going towards deployment, large-scale deployment and industrialization. What it's now has to be done is to upscale all these small demonstration units. So basically, this is what's going on now in Europe. So to scale this up into higher power ranges and build up an industrial line for it, because everything is now made by hand, and of course this is very, very expensive. Yeah? And this is definitely the route up to the next 5 years, and after 27 the hydrogen value chain should be ready.
Okay, what percentage of cost reduction would you see?
Yeah, actually we are more than around 5,000 euro per kilowatt, and in 5 years it will be below 800 euros per kilowatt.
Wow, divided by 6.
Yes.
Wow, that's a strong message. For the ones that don't know, IPCEI, Important Projects of Common European Interest, is kind of the Champions League of developing new technology value chains, and it's an honor to have you and Christoph Industries in this European flagship initiative, but you're also in Horizon Europe projects.
Yes.
How do you select partners which might be now in front of the monitors?
Yeah, so basically we are very open to collaborate. So we have a very, very good network already with a lot of industrial and research partners, driven also, of course, supported by Hydrogen Europe, where I am honored to say that we are a founding member of Hydrogen Europe, and as well, I'm very happy to be part of the Austrian initiative with a BNG as well. Yeah.
Thank you so much. Richard, some questions from audience? No, thank you so much, Richard.
Yeah, thank
it
you
was a
very
pleasure
much.
meeting you here.
Thank you.
We're moving on to Mr. Radija Nunic. He's the Director European Sales and Public Affairs and Alternative Fuels at Worthington Industries. Worthington might be very well known for cylinders, gas cylinders, and also for hydrogen cylinders made in Austria.
That's correct. Many thanks for the kind introduction, Mr. Puttinger, and thank you all for having me here today. I'm going to represent today a part of Worthington Industries with the new name Sustainable Energy Solutions. That's a division within Worthington who is focused solely on clean or sustainable energy systems. What does it mean? At the end, today, if we speak about decarbonizing our society, economics, everybody started to speak about hydrogen. Hydrogen is nothing new. We know it for a long time. But now we speak about the application which can bring us to the next level. Well, why do we speak about the hydrogen? Because the hydrogen is the only non-polluting energy carrier or source of energy for our vehicles which can be utilized without polluting our earth. That's also not a secret. Nevertheless, everybody speaks also about green hydrogen, which we don't have enough. We don't have it available. We don't have enough electricity to produce green hydrogen in big quantities and fast enough. Everything is actually not enough. We are lacking in every sphere of the business. We don't have enough electricity, not enough green power plants, hydro plants, not enough windmills, but also not enough electrolyzers. That means whatever we do, we need to do it quickly. Why? Because there are some country leaders, as we have learned, that have forgotten that we are living on one world and we are one species. So what does it mean? We have a lot of conflicts in this world, and this is a map showing current conflicts, one of which is only the recent one which we all know of, the war in the Ukraine. That is not the only conflict, as we have seen on the map, but these conflicts need to stop. And we need to do our best to stop these worlds worldwide and enhance cooperation in order to reduce the carbon load on our planet, to start producing more hydrogen, to clean up the atmosphere. And we need to do it fast. Why? Because the global warming is not a myth. Even the colleagues from the other sea have realized that one. So the temperature is rising, and it's rising much faster than we have anticipated, like this nice illustration shows from NASA. So we might be reaching these 2 degrees C plus much sooner than we have expected. So whatever we do, we need to do it fast, and we can only do it together if we are increasing the level of our cooperation. So now we know that we need to have a hydrogen. It should be a green hydrogen. We don't have enough. And everybody speaks about different colors of hydrogen. Green, blue, yellow, whatever it is. It's clear in which direction we should go. But for the time being, we should rather focus to get clean hydrogen, to speed up the decarbonization of our systems, and to secure or to improve electricity or availability of the energy per itself. So also that is not a big secret, and only here we can do it together by cooperating not only locally in Austria or in Europe. It must be an international cooperation, as we have heard and seen so many times. So only together we can speed up the implementation of alternative fuel systems. We have to remain also technology open. So it's not only hydrogen, it's not only battery, there are different technologies and all of them work together. We are going also to need furthermore fossil fuels and also e-fuels, hopefully. And all of that shall help us to minimize the risk of blackout, reduce the dependency on oil and gas from war-raging countries, and also help us to speed up with the implementation of the hydrogen economies. Also here we need still to do a lot of work, especially in Austria, where we still have no clean or clear hydrogen strategy. We need also to make the funds easier available to the companies and make sure that there is a certain investment safety for the companies who are venturing that business. I'm happy to see that many companies in Austria are already working in that sphere, but we can do more. And that being said, I mentioned we need a global cooperation, but we have to also think very much locally. How can we bring more value to this business? So there are many ways how to reach the goals, and one of them goes to the decisions which way we want to go and what decision we make. And there is one very famous former Austrian gentleman who said, there is no other way to get to the results as to do something, so you cannot have results and excuses. You can only one. And I am for the other way, so that we do not utilize any excuses, but to move forward developing our technologies. So what is the role of Worthington Industries? Worthington is a company, again, very famous for production of composite high-pressure cylinders, but in Austria we have been mostly known for steel high-pressure cylinders, which have been produced in Chemie by Gumming since more than almost 100 years. So, thank you. So we produce steel high-pressure and actually type 2, composite type 3 and type 4 cylinders for stationary application, for mobile integration like in the buses, trucks, cars, but also for the transportation of gases from the mother stations to the daughter stations, from the place where the hydrogen is produced, where the user is sitting. What you can see here, just one of the modules, a smaller one developed for transportation of natural gas, hydrogen, you name it, we have it. We have been investing more than 10 million euros over the last 3 years in Austria to build a state-of-the-art facility for production of composite cylinders. But also in the same facility we are going to, or we are already producing onboard fueling systems for various types of vehicles. But it's not only steel cylinder like you see here, or type 2 steel cylinder with carbon fiber, aluminum cylinder winded with carbon fiber, or polymer cylinder. We do have also further components in our hand, so that means there is a German facility with the name Pipv who is producing so-called onboard components for the onboard fueling systems, gas street components. So we can offer everything starting from the film receptacle down to the pressure regulator and various types of filters for the fuel system, which you see here, an example of hydrogen bus or hydrogen truck. So, coming to the end, I think I have 2 more minutes. That means with our group, which is based in Austria, with headquarters in Austria, we do provide already today cylinders, gas street components, onboard fueling systems, and gas transport containers for the hydrogen economy. We do have a very strong engineering team, unfortunately not as big as at AVL, but we have something to strive for. And with these components we have today, we are already in place of serving all of the current demands of the market, starting with pressures from 200 bar up to 700 bar for various applications, also for the storage systems on the ground, for the hydrogen refueling stations, or other means of transportation. We are considered by many of our customers as one-stop shop, where one can get all of these storage solutions. And being a part of the large organization, we are also a very stable partner. So, that being said, how can we help you?
Thank you so much for an impressive presentation, not only giving the big picture, but also clear answers, clear action to be followed. Questions from the audience? How can they should be of service? Which customers should be addressed with this question?
Basically, we serve big variety of customers. Industrial gases companies like the gas majors Linde, Air Liquide, with the steel high pressure cylinders, but also other engineering companies who are developing various solutions. We have been also cooperating in the past with Fronius for some hydrogen cylinders, steel ones, but as far the OEMs are concerned, truck and bus, we provide the bus makers with these hydrogen onboard fueling systems which one can find on the roof. So those are our customers today, but we look forward also to develop or to help developing the hydrogen infrastructure to enable that these vehicles are not only filled on some depots, but also once these fueling stations are built and along the 1010 corridor, that we have also enough gas available for those vehicles.
What is your market expectation for hydrogen cylinders?
Growing. So we see that not only in the case of Worthington, but also our competitors are very much expanding their production capabilities, and that is going to continue. Also here, the same is valid as I mentioned before for the other technologies. There will be vehicles which will be running at high pressure, hydrogen high pressure, 350 bars, or long haul application, 700 bars, like we have seen on other samples. And later in the future, when we have enough hydrogen to liquefy it in big quantities, which is expected by Daimler, for example, we will see also trucks and coach buses running with liquefied hydrogen more than 800 kilometers or 1,000 kilometers, like diesel buses and trucks are running today. So we see a lot of potential here.
Thank you, Radisha, for your engagement.
Thank you very much.
Question, two questions. Now they're coming up, as I should close down. Two questions in a row.
Do you also make fuel stations for hydrogen along auto routes or so?
No, we don't. We would rather prefer company Fronius to remain the main partner for this one.
Thank you, Magdalena.
You've said that you have customers all over the world. How big is the market in international area compared to the Austrian area?
Bigger.
So, while I'm responsible for that part of the business, but mainly in Europe today, and we have been seeing some interesting figures from 2018 made by FCHU. They have been projecting something around 1,000 buses in year 2030. Also something about, if I'm not mistaken, 6,000 to 7,000 trucks and so on and so forth. We see this a little bit differently. We see that we have reached already more hydrogen buses in service than projected 4 years ago. Also companies like Solaris, like Daimler, like Van Hool, and other bus makers are really pushing forward to develop these buses, and especially the trucks. When we speak about 1,000 buses till within next 7 years, the truck market should be 10 times as bigger. So it's only 10,000, let's say, which would be the minimum figure. But we want to have only 2,000 of these trucks in Austria, per latest study where Deloitte and also AVL was part of with Worthington. And the European Union would like to see approximately 100,000 of these trucks in service, and every 200 kilometers refueling stations. So the market expectations are big. Now we just need to do more than we talk.
Thank you so much, Radisha Nonic from Worthington Industries. Thank you so much.
Thank you.
Thank you. We're coming out to the end. I give you a short outlook what's coming up next. At 3:30, so in 10 minutes, we have the next breakout session on artificial intelligence and energy transition, as well as further B2B matchmaking. Thank you so much for joining this session on hydrogen. I hope you take away that Austria's real hotspot in terms of hydrogen research, hydrogen applied research, and hydrogen business, bring it down to the road. And I'd like to close with the words that were introduced beforehand, with the words of Arnold Schwarzenegger, born in the GreenTech Valley. Let's work on better, faster and more effective results, especially for green hydrogen systems. Action.
Hello and welcome to the, I think, second breakout session of today, or at least the second breakout session in this room on this live stage. For those of you who are watching us at home or at work or at the beach on this wonderful sunny day here in Vienna, at least. Hello to our hundreds of participants around the world. I hope so far you had an interesting conference during this GreenTech Day, the very first GreenTech Day organized by Advantage Austria. We are a part of AI Austria and have the very special pleasure to host this breakout session on AI and the energy transition. I don't have to explain in great length nowadays the significance of the need to better manage energy resources. And probably I also don't have to explain the many areas where AI has already proven to be very valuable in optimizing processes and reducing costs. Of course, the field of energy, utility, the grid, is a very sensitive market, a very sensitive area. The thing that we are trying to achieve today, together with you, is to have a look at how AI is actually applied in these very special domains. And we will introduce two fascinating speakers to you who will not only give you their presentations and their 2 cents on the topic, but also there for you to interact with them. So you're here live. You are also here live watching the live stream. So right up front, I would like to remind you that you can ask what's on your mind and hopefully walk out with a couple of learnings that you will then use to further on and strengthen the use of AI for good. But first of all, let us tell you a little bit about the mission of AI Austria. And Clemens here is the chairperson of AI Austria. Wait, I can give you my mic if you want. And Clemens takes over.
Yeah, test failed. Test passed, great. Yeah, thanks a lot for showing up, especially people from AI Austria. May I ask who of you does already know our organization? Great, there are 6 hands and 5 people, so I don't know how to count the lady in the last row. No, it's actually, we formed in 2018, it was almost to the day ago, it was just a couple of rooms further, it was down in the Julius Raab Saal. We are like the Austrian non-profit organization for all things artificial intelligence. It's like, yeah, what does non-profit mean? We don't take any official donations or something. You know, if you have a non-profit in Austria, that's always a little bit, you know, sometimes you have to hold your nose, but we're not like that. What we're gonna do, I think you could switch to the next slide. Yeah, so what has happened in the last 4 years, and don't worry, I don't want to put you to sleep, it's already afternoon and very hot. Lots of the things that are going on are events like this one, like very forward-looking personalities like Konrad, the gentleman who is organizing this event, asked us to put together a panel or a special session, how does AI fit into construction, in green energy and so on. Besides that, we built up a so-called AI Academy. This is a program for people which are coming not from a technical area but have an interest, what can AI do? And even more so, what can AI not do? Thinking of the Terminator and WALL-E, for example. Last but not least, it's very large conferences, because as you might have noticed, my colleague here, Matthias, is wearing an incredibly cool t-shirt. And this is the AAIC, this Applied AI Conference, which we also started 4 years ago. Matthias will tell you more about it later. But this is actually also one of the, let's say, of the outcomes. Just 2 months ago, we had a global event that was the AAIC on energy. And there we had a couple of companies talking about AI applications for energy preservation, you know, better utilization of resources and so on. And yeah, also the former Prime Minister of Austria was there, so you could say it was a very high-level event. What sticked in our mind, it is also, especially with regard to today's event, you can do a lot with AI. So if you think about grid optimization, for example, or virtual power plants and so on, but there are still some regulatory hurdles to clear. So when putting together today's panel, we were looking for companies where you can, out from the get-go, interact with them and already start to lower your CO2 output and lower your energy consumption. So this was basically one of the important things for today. Yeah, I think as far as the rest is concerned, yeah, with regard to the time, I spare you the details. So I hand over to Matthias to talk a little bit.
Of course, also mentioning where to find us, and we'll share the slides later, but let me just quickly go over that. We of course work with a worldwide network of partner organizations, and one of the core things that we do where we connect people is the Applied AI Conference. Just imagine there are people in the energy sector, for example, that are very well aware of the problems they face in their everyday work. Then also think about people in the field of AI, who are very well aware of what AI, machine learning, deep learning can do. The basic idea of Applied AI Conference is to combine these domain knowledges to create sensible use cases. And we organized Applied AI Conference with Advantage Austria and with other partners for a couple of years, or you said 4 times, and also for 4 years. And I have a laser here. How cool is that? Also organized more specialized gatherings like AI in forestry, AI in logistics, in fintech, in semiconductors, in energy, where we were able to really tackle a very engaged crowd. Yeah, and the more specific you get in connecting domain knowledge, AI plus X, the more sensible the use cases and the discussions are, in our opinion. Upcoming, also taking place here, Applied AI Conference 2022, organized with Advantage Austria and with a special focus on sales and marketing. You don't see that kind of topic in a conference a lot, but we really want to look behind the scenes. Also, of course, fintech in the end of May and health coming up in autumn. Yeah, without further ado, please follow us. Please join our community if you're interested in learning more. There's a QR code. There are contact details. And Clemens, what do we have prepared for today?
The future. No, actually the present, because the future, as I mentioned before, grid optimization and so on, we want to make this today as interactive as possible, because after all, if you don't ask questions, you could also hang around on YouTube at the beach. So please, if you have any questions to the speakers or in general, just shoot us questions, either for those of you in the room, raise your hands. Raise one hand to the lady in the last room, not 2 hands. And Slido, because here, for example, and I would also like to welcome with me on the stage Martin Gruber, who is the Director Europe at Brainbox AI.
One more thing.
Yeah, I always forget this one, sorry.
Okay. Many of you are familiar with Slido, and to those who are sitting here today, we have even more people joining us online, and we don't want to discriminate anybody. So to interact with the speakers, we all use slido.com. So how that works is basically you pull out your phone, either here or at home, or open another browser tab, scan that QR code. For you at home, you don't have to scan the QR code. You can just enter slido.com/AI Austria. Let me just quickly try that here. And voila, you are at the Slido page and can ask questions. And more importantly, you can vote up other people's questions. So to make sure that we only ask the most relevant questions to our speakers today. Hello, yep, thank you, Anonymous. This is working, yeah. This is working. Also for you at home, slido.com/AI Austria, type in your questions and vote up. You cannot downvote other people's questions. It's that nice. But upvote other people's questions that are of interest to you. Everybody clear on that? Yeah? Phone questions? No raising hands. Good.
Great. Lots of raised phones. Works. Yeah. Now for let's say our two. Yeah, this is having a little bit of a. Now it works. Now for two speakers of today. Yeah, with the first of all, we are very lucky. It's actually an amazing coincidence that we can welcome the company Brainbox AI here. Why is this an incredible coincidence? First of all, they are one of the largest, if not the largest, optimization company when it comes to energy management in buildings. Where the coincidence comes into place, let's say they are a very late stage startup on the way to a unicorn, and they will most likely open their European headquarter here in Austria, in Vienna. And the person here is the Director Europe with me on the stage. It's Mr. Martin Gruber.
Thank you for the introduction.
Great. Yeah, this is not Martin's company because this is Gnister, but you can also stand up, Mr. Benjamin Merzinger. It's the Austrian counterpart. Great. Yeah, environment is good. Now maybe a little bit Brainbox environment, and yeah, perfect. Now we're ready to roll. So
that's perfect.
The stage is yours. See you in 15 to 20 minutes.
Absolutely. Thank you so much. I'm gonna start with a quick statement because I just read it when I came here in the tram. So ESG is the greatest gift for the built environment because it's the vehicle that we can use to push the industry to adopt technology and align with values. It's not theater, it's very real. And this statement comes from a very popular guy. He's the COO of Oxford Properties, one of the biggest property owners in the world. And I think that statement is very interesting. And if you look back in the morning session from Carlo Ratti, he quite said the same, right? He said we need to listen more into buildings. We need to make or bring buildings more to life by using technology. And this is the thing what we do within Brainbox. So we're optimizing HVAC efficiency by using AI and cloud computing. So that sounds now super sophisticated, but that's not that complicated as it sounds. But let's go one step back, why Brainbox was founded. So if you look into the industry and the GHG emissions, we have the goals we have in place with the climate agreement in Paris. We know that around 20% of the GHG emissions are coming from buildings. Today I heard even that in US it's 40%. So you see buildings have a major impact. And for us, the commercial buildings are very important. And why it is important is because when we look at the climate agreement, which will be neutral in 2050, 80% of the building which we currently have will be still there. So that means this kind of building have a huge impact if we can reach the goals or not. Right? Secondly, if you look into the energy consumption of a building, 45% up to 70% when it comes to shopping malls is related to heating, ventilation, and air conditioning. And 30% of that energy is wasted. So it's a huge amount what we lose in this kind of area. And when you look into the challenges, what commercial real estate has is, you see that obviously on your private households, your energy bills are increasing. We see that, for example, in a building in Italy we started, and the price per kilowatt hour was 16 cents, and now it's 39 cents per kilowatt hour. So you can imagine, if you look into a building of 80,000 square meters, how big the impact it has on the energy bill. So it's all about reducing the energy costs, the energy, the emissions, and finally keep the comfort. Because we learned in the last 2 years how important it is to have good climate in the rooms, right? To have good energy. When you look into shopping malls, they are looking to improve the comfort to make people stay longer in the malls and all this kind of stuff. And as well, millennials are putting a lot of pressure. Because what we currently see is that, especially in the office space, the prime locations are getting more and more important because millennials are going to the big companies, and one of their first question is, what are you doing for GHG emission reduction? And one part of that is obviously the building you're sitting in, and this is where we have an impact on. So, and then finally you have different stakeholders in the building. So I'm coming from the digital industry, so I'm not a real estate expert and not an energy expert, I'm rather on that side. And real estate is complex because you have different goals you want to achieve, right? If you're an owner, you want to decrease OPEX, you want to decrease Capex, and obviously you want to increase the value, the equity value of your building, because the average time you keep your building in your own assets is normally around 8 years. So there are a lot of investment companies currently who are investing in buildings, renewing it, making it smart, gaining new insight, as Carlo Ratti said, bringing life into the buildings, and then selling it with a new value, right? Then there is, you see it now everywhere, that there's new management in terms of sustainability. So people are looking into their financial reports to put the sustainability report on top of it, right? So they are committing to goals. Investors are asking for that. Banks are asking for new investments, what do you do for GHG reduction? So there's coming new kind of pressure in that level. And finally, you have the people on the ground, the asset managers, right, who are looking to make the best out of their building, but obviously they are very busy, so they are looking for technology to help them to optimize accordingly. And if you look into a self-driving car, a Tesla, what is the Tesla doing, right? The Tesla is driving and then looking what is happening in front of him. And then if a person is crossing the street, the Tesla reacts accordingly and stops the car. And our founder, he's 35 years in the HVAC industry, so he was doing big refurbishments. And then he was sitting once in that car and said, why don't we do the same with buildings? And this is why, because of the reasons I mentioned before, and because of that fact, BrainBox was invented. So in the end, what we do is we bring heating, ventilation, and air conditioning into a predictive and self-adaptive equipment using AI and cloud computing. And my first question to BrainBox was, when I joined, or before I joined them, I said, listen, I'm coming from the digital industry. Everybody says we do AI, but I want to understand if really AI is behind the game. And if you look in the cycle, that's exactly what we do. And obviously, I was confident. That's why I'm standing here today. So first of all, we learn about the behavior of the building, right? And by learning the behavior of the building, we use the data of the building. We use weather forecasts, meteorological data, like, for example, we know that the thickness of the cloud has a major impact on the climate in the building. We use energy tariff structures, and that we squeeze that data together, and because of that, we can predict the status of the building 2 to 6 hours in advance with a very high accuracy. And instead of making the building reactive, when the temperature sensor says now it's 21 degrees, you can cool down, we know it 6 hours in advance, so we can modulate the equipment accordingly. And this is not big adjustments we do. These are minor adjustments, but these minor adjustments finally lead to big savings, right? And then what the next step is coming, we are reacting in real time. So every 1 to 5 minutes, we read out the data and we adopt accordingly. And obviously, the longer we are in the building, the better we get. And then finally, we have the possibility as well to make adjustments on the grid level. So that means we can predict when the building needs to be heated or cooled. And we know from the grid if we have green data or if we have cold data. And because of using that more efficiently, we can say, okay, now there's green data available, maybe we preheat or pre-cool the building accordingly to use more green energy and avoid coal and gas, for example. So all these kind of possibilities would never be possible without using the data and without AI, right? Because you would not send a person every 5 minutes down in the cellar and doing some kind of modulation, even though he would not know what the weather forecast will be. And what we can achieve is, and these are not numbers we use as a marketing material or from studies, these are numbers we see in our real buildings. So we are currently enrolled in 300 buildings globally with managing around 1 million square feet. And we have 4 goals we want to achieve. First of all, it's reduce the energy, the GHG emissions between 20 and 40%. Reduce the energy costs. As I already explained, it's a big pain currently. So A lot of real estates are approaching us now because of that fact that the energy bills are heavily increasing. So we are looking into decreasing it up to 25% on HVAC side, which means on the entire building it's around 10 to 15% of energy consumption. If you look in a shopping mall and it has an energy bill of 1.5 million, 50% is quite a decent number. And then of course we improve the comfort. So we look into keeping the comfort, the CO2 level and so on in the building accordingly, because in the past there were some companies who were just saying, okay, we're going to reduce, that's me, sorry. We're going to reduce the energy consumption by reducing the temperature in the buildings, but that's not what we do. We keep the temperature and the comfort. It's very, very important. And finally, we increase the lifetime of HVAC equipment because we use it more efficiently. We can increase the lifetime. That means as well lower investment costs and finally as well lower maintenance costs. And I brought one building example with me, which is quite a significant. It's prime A location, an office building in London, 55,000 square meters. And we started the entire project, and normally what we do is we validate the building accordingly if we have an impact, because every building is a snowflake, right? So every building is, in terms of equipment, different, in terms of technology, different. So we have to really adopt from project to project accordingly. But what we achieved with this is 15% of energy savings, which means 637 CO2 tons per year, which we can save on that building only. And then if you scale, they have 13 to 15 buildings around that area as well. If you scale, that's quite a significant. So in terms of energy savings, and that was before the Ukraine war, it's 1.9 million pounds we save per year. So you can see what kind of impact we can have, and this would not be possible without using the data which we have available from the buildings. But we're talking about the state of today, but we're talking about the future as well a little bit. So what we are aiming for is, it's the next phase, and we were at the COP26 in Glasgow last year, and we won the first prize for Tech for Climate. We're looking into the next level of what we can do with building in order to bring more flexibility to the grid. And if you look on the grid, this was before, right? There was straightforward connection from different layers of energy. Then we added solar, PV, wind energy, whatever. Still, there is no flexibility on the grid, and it's intermittent. So we are struggling, and everybody knows with the change of the EV cars, there's a lot of demand where the grid providers are not capable at some point of time to deliver anymore because the infrastructure is not there to provide such kind of demand. And what we are looking for is exactly that, bringing in more flexibility to the grid. So that means we cluster the different buildings together and use the building as a thermal battery. So that means we can go in the direction of load shifting, load shedding, and as well use the energy accordingly. And if there is too much energy available, we can bring it back to the grid and bring therefore flexibility. So we can predict the demand of the energy consumption on the grid and therefore help the energy provider there. And we are already starting with the first prototypes here. One of them will probably with wind energy here in Vienna as well. And we have another one in Australia and in Montreal. And that's just as a close down for you to know, Brainbox, I mean, Clemens already introduced it quickly, but we are a Montreal-based company, founded 4 years ago, on the market since 2.5 years. And since that 2.5 years, we are rolled out, as I said, in 300 buildings globally. And we're heavily increasing our footprint here and looking into very big portfolio owners to make an impact. And now the next step is to bring the energy providers in the game and even increase the reduction on the GHG emissions again up to 50% on top of what we already do on the buildings. So that was it from my side. Very quick intro. I think we keep the questions till the end, or what's the plan?
No, we do it now.
Okay. Good. Any questions from the audience here? Thank you so much in the meantime.
Is this working? Yeah, we have a couple of questions, and I'm sorry, if you still want to ask questions, please type it into slido.com/AI Austria. I'm very sorry, we don't want to give you the advantage of just raising your hand while our people are watching out there in the stream. But we have already some questions here to get started, and you can also vote them, and I will just ask them. Somebody asks, is your solution suitable for non-commercial real estate?
No.
No.
The reason is quite simple. I mean, I assume you're referring to residential, for example. The issue on residential is that normally the rooms are controlled individually by the occupant. So that means we, with technology, cannot have an impact on that kind of rooms. That's why we focus on the commercial buildings.
All right, I hope that answers the question.
And just to add one sentence, so to bring clarity, the majority or the best impact we can have is currently on office, shopping malls, multi-site retail, hotels. It depends, hotels, it's sometimes a little bit different, exactly due to the same reason with residentials, and as well logistics.
All right, and there are a lot of questions coming in, and the next one on our list is, how do you deal with data protection concerns in the public sector, for example, train stations or government buildings?
That's a very good question. So basically, first of all, I mean, we are SOC 2 certified, so it's the same equivalent than we have here in Europe for ISO, so we are going the ISO route currently, and we use data centers here in Europe for European customers, first of all. Secondly is, we have a secured connection to the cloud, which helps us to anonymize the data, and we only transfer data to the cloud, but not vice versa back. So that gives us the possibility to make sure we don't bring data to the building which should not be there, and still the data is part and owned by the customer.
Mm-hmm. Anyway, very sensitive data on how a building is using, especially if it's a company using its energy. Not sure if it falls under GDPR because it's individuals, yeah. Next question. 300 buildings doesn't sound much. Can you put this into perspective?
300 building, I mean, I believe it is a lot. After 2 years being on the field, I mean, it's 1 million square feet, right? So we are focusing on buildings bigger than 10,000 square meters. That's first of all a big thing. Secondly is, till you onboard the building, it takes time. So you have, obviously, as everything in AI, you need to train and learn about the behavior of the building. That normally takes up to 3 to 4 months to learn about the behavior of the building and then map our algorithms to it. So obviously, considering that, you don't plug in and then it runs, right? That's not. And I consider 300 when they are deployed. And secondly is, real estate is not the fastest moving industry when it comes to digitalization. That's fact, right? I'm coming from digitalization, so I saw many companies in manufacturing, retail, and so on. But real estate is, the mindset is sometimes, not for all of them, but it's not there yet. And as I said before in the beginning with the statement, is there is now a push for real estate to be digital ready, and big insurance companies who invest heavily in buildings have seen that, and like Oxford Properties, they hired 150 people just for digitalization, right? So this is a matter of fact where you have as well to educate and convince that technology is there to help. And these kind of facts rely on the 300 buildings, which we do.
Thank you. So I understand that these are tailor-made solutions, and I liked your expression where you said every building is a snowflake. Yeah. Introducing the next question, how do you initially assess a building before applying the AI solution?
That's a very good question. Thanks for asking that. I mean, that's what we do. So we want to make sure that we have an impact on a building before we even install the technology. So we need to understand what kind of equipment is in there, what is the energy consumption of the building roughly, and then as well understand what kind of technology is already in the building. And there's a very simple way forward where we do a quick observation of that. It's a little bit back and forth in terms of information exchange, and then we are quite quickly able to give an indication in which terms of savings we can generate in a building to give an outlook what kind of impact we can have.
Thanks. And out of curiosity, what's the time frame for such an onboarding process?
As I said before, it's the main part is the onboarding period, which takes normally 2 to 3 months to learn about the building. For the information gathering, it's 1 week. We quickly collect the data and we analyze. Then we install the technology and then we let it run for 2 to 3 months. We're getting better and we are getting more automated. Generally speaking, the effort currently, the main effort on the onboarding is the so-called data mapping. So each and every building is a snowflake and each and every building management system is configured individually. So we need to normalize data. And this is a very manual effort currently. We are on a very good way to soon release an automated tool to do that. But for now, it is a manual thing we need to do. And this takes the most time in the onboarding fee. But normally after 3 to 4 months, you're gonna get the first savings on the billing.
Thanks. And people reacted to your last answer, and Anonymous is asking, how do you deal with seasonal effects, for example, summer versus winter, when only learning for 4-month period?
Again, a great question.
Smart question.
That's something where we have experience in, and what we do is within the onboarding period, we interpolate that and we can bring our experience in that to see how does it impact the entire year. So we know in the cooling season this kind of equipment has more runtime, so we're gonna have a major impact on that. But in the winter season, we're gonna consider this and that. So we're gonna cover that, and that means after the onboarding period, we're gonna provide a runtime analysis which says clearly, based on the data we see in the building, this is what we estimate we can save. It's not a guarantee, it's an estimate, but this covers seasonality as part of it.
And now you can still ask your questions and upvote others. For those who are here, you can also approach our speakers after this session and talk to them, or arrange virtual meetings just if you have something more specific or individual to discuss. So the next question on the popularity list is, how fast does your program react to differences of the building? Suddenly more people on airport hall, for example. This changes the temperature and...
Yes, so we read out the data every 1 and every 5 minutes of the building. So that means we can react close to real time.
Interesting. And are there any possibilities to get green building certifications?
So we don't do the green building certification, obviously, but what we can do, and this is what we're heavily aiming for, is to provide our data for certification purposes. So that means certification companies will not need to dig deeper into the building. We just provide them the efficiency data out of our technology, and that helps them to be faster in the certification process.
Interesting. This question and the one about GDPR is always coming, but I'm gonna ask it. Are you hiring? Somebody, not me.
Yes, we do drastically.
You check out their website, guys, come on. So, how long does it take until Brainbox AI can deliver results? I mean, you already touched upon that question.
Roughly in month 4.
Wonderful. And the last one to finish up. Oh no, another one came in. How many people do you want to locate in Europe? Like meaning hiring, I guess?
That depends clearly on how fast we grow. I mean, currently we have 160 people spread over the world. We finished a Series A funding in November last year with 26 million coming mainly from ABB. And obviously, the more footprint we have, the more people we add, and a lot of investment is going into the development of the product. So you can estimate around 100 people are just developers on our side. And we need that in order to be capable to deliver. Because as I said, every building is a snowflake, so it has some manual efforts in the beginning, and therefore to deliver accordingly we need people. And when it comes to further development, what I showed you as an outlook, this is something we are already developing, but this will require many, many people.
I mean, the questions were there about hiring and how many employees you plan in Europe, etc. But it actually doesn't scale that quickly as other software solutions, for example. So my question would be, do you also work with implementation partners, like third parties that implement your services, or do you have that on your roadmap?
So implementation itself, when it comes to implementing in the building, we do work with, especially in Europe, we only work with partners, because otherwise you cannot scale in different markets with different regulations, different languages and so on. When it comes to product development, that's everything 100% in-house.
Great. And last one, and this is more general, so maybe you can touch upon that in a general view. Are there smart meters necessary in the buildings, like meaning in general?
I mean, not necessary, but if they are there, it could give us further possibility to optimize. So as always in AI, the more data we have, the more we can do. And that means, I mean, we are working with many big companies, portfolio owners who have different strategies, and one of them is optimizing the energy consumption of the building, but on top, validating what kind of sensors to put on top in the building to improve the possibilities there. And obviously we are gonna react to that, and when it comes to heating, ventilation, and air conditioning, we're gonna consider.
Great. And we got another one. I'm sorry,
Yeah,
I'm not letting you off the hook yet.
No problem.
How do you handle data labeling on that scale? Every house is a snowflake and thus needs to be labeled as such.
We have a standardized in-house process, which is part of our IP, obviously. But
sounds like a standardized answer to that question.
Yes, it is. But yes, there is manual effort, but we are quite. So you can imagine if we do data mapping in the building, it normally takes us 2 weeks roughly. I mean, 2 weeks means 10 days of effort to do so. We are already capable to shorten that, and finally we're gonna have a tool fully automated to do that. That's part of our DNA.
Great. Brainbox AI, everybody. A round of applause and
thank you so much.
Yeah, thank you very much, Martin. I mean, yeah, actually, it's a positive reason why we are behind time, because there came so many questions from the audience. I mean, we started with a company using AI to increase energy efficiency, to decrease power consumption with a red, white, red flag. So I think we stay in that lane this time with a different red, white, red flag. From Austria, Benjamin Mörzinger, Chief Product Officer of Gnista. Yeah, I remember that one finally, because in the banner it was still incorrect. In the field of AI and, let's say, energy, Gnista is one of the shooting stars in our country. For example, they raised a seed round in the January of this year. This was a pre-seed round. This was one of the very few 7-digit pre-seed rounds, actually the only one I'm aware of even in this country. And yeah, the funny coincidence, I even went to lunch with your investors just before you signed that investment, but I didn't know to sign with you. That was a pure coincidence.
Cool. Yeah. Nice people.
So without further ado, your half an hour of fame, or how much you ever need, and please ask questions. But this is working wonderful. This is good. So see you.
Thank you so much. Yeah, hi, I'm Ben. Let's make it really quick. So if you only have 20 seconds until you have to do something else. We at Gnista.io, we hope to be Brainbox AI for industry in 3 years. If you have more time, I can give you a more nuanced answer to who we are and what we do in the next, let's say, 10 minutes. So Gnista.io is not able to process the slides. Can you please give me the next slide? Yeah, that looks great. Yeah, so challenge, yada yada, minus 40% per energy per car manufactured is a challenge. That's a real goal of a real manufacturing company. we all need to reduce our energy footprint. That's probably a given, and that's a challenge, and that's the challenge that we want to do, to tackle. Because at the same time as people are having very, very ambitious challenges, they also have goals, they also have the challenge that processing data is really hard. And not everybody has an in-house tool that makes labeling, processing, for example, house data very easy. Especially not manufacturing companies have that. So next slide. We try to do that. Who are we? I myself am Benjamin. Together with Anna and Marcus, we are the founders of GreenTech. We have been founded in 2020 as a spin-off of the Technical University in Vienna. We have a great investors team. Also, some of them are here. Hi. And mentors as well, and we won a few prizes. So this is us. We are located in Vienna. If you happen to come to the second district, please visit us any time. Next slide, please. Yeah, so let's go back to the problem and all the stuff that is actually preventing us from using data that is already there to make industrial manufacturing processes more efficient. Just giving you a short overview why we should even bother doing that. A third of our global energy demand is going into industrial manufacturing processes. So no matter what you do in your private life, this is much more important. So why are we not doing anything about it? We are doing a lot about it, but not as much as we should. So this is a messy picture depicting a very messy process. People are sending around CSV and Excel files and PDFs and talking to each other, sometimes screaming, sending emails, trying to make sense of data that is already there. And that leads to a lot of frustration and oftentimes people not really using data, apart from within research projects, which is where I'm coming from. So let's do something about that, we thought, and let's reduce complexity. Next slide, please. Thank you very much. This is what we try to do. This is our business model. Please don't copy that. Yeah, we offer energy efficiency as a service. A large part of that is AI and software, but our customers don't tend to be interested in software and let alone want to buy that. What they want to buy is more energy efficiency, being more efficient, doing more with what we already have. So we provide that with service. How are we doing that, you might ask yourself now? Well, we take the available data, we take the knowledge about the data from experts that are already in the house, the people that are sending PDFs and Excel files around. We collect all that, combine it in our platform with our experience, make it processable, and then send over improvement measures. That's it. Yeah, simple as that. I think I'm done. No, I'm not. Next slide, please. Yeah, we have been trying to build our product not alone in a silent chamber. We have been talking to a lot of industrial manufacturers. We have also been implementing a lot of pilot projects already, also with energy providers, mostly in Austria. And we have, and that's the second part, besides the software part of our business, we have a lot of partners, because we are not necessarily able to provide all the energy efficiency measures for all the industrial manufacturers in the world ourselves. We need external partners for that. And we try to bring their knowledge to a worldwide audience very efficiently via our tool. So partners help us a lot. Yeah, next slide, please. So this is just one of many use cases, maybe again referring to the previous speaker. Another problem that we have, if we want to address industrial manufacturers, there's not necessarily one thing that most of the time helps. It really, really depends on which industry we're talking about. Even worse, not only the industry determines what kind of measure should be followed, it also depends on the certain site that we're looking at. So not just a very vast heterogeneous data source is the problem, but also the things that we provide to them in order to operate it better. It's not just one thing, but hundreds of potential things that we need to evaluate. So this is just one of a few. HVAC systems, we have been talking about that. This was in the industry, are also used. You can save a lot if you reduce if you optimize the operation of your HVAC systems, which are used, for example, to control the temperature and the humidity within manufacturing plants in the semiconductor industry. We did a pilot with a large Austrian semiconductor company on that. So how are we doing that? Maybe just very briefly. Setup workshop, we need to make sense of the data that is already there, very similar to what has been told already. Building a digital twin, also very similar, but a specific part of it. So we need to build a simulation model of what is already deployed. Now, however, in context with a production demand. So somebody needs this energy that is provided by the HVAC system. And then we measure the savings that we can achieve and that we achieved since we have been changing the running system. Okay, let's go to the next use case. Another one is obviously cement industry. Just to give you a very brief idea, per year a single cement plant needs energy that costs 16 million euros. And that was, I think, with the numbers calculated again from last year. So 16 million euros just for energy in cement industry. At the same time, cement is relatively cheap. So a large part of costs in the cement industry are energy. You can reduce that, you can optimize your manufacturing processes using data that is already there. However, you hardly do that because there are no people in-house that are really able to do that properly. So you model energy demand. You could, for example, link that with energy prices and then only use energy when it's super cheap. And then again, report savings that you were able to come up with by doing so. I even did a calculation on could we use a cement plant as an energy storage? So instead of pumping water into a hydropower lake, just switching off a cement plant. It's not a really good idea. So if you're interested in that, get in touch. I can tell you why. So yeah, and then the last use case that I brought with me. Next slide, please. Yeah, that's a very messy picture, but it shows how we can use peak load reduction. So we can reduce the peak loads of a packaging manufacturer and thereby reduce the costs. That's super simple. That's a super simple concept. Anybody in the industry knows that peak loads determine the energy costs of a plant. However, finding peak loads and then finding the root causes for said peak loads is incredibly messy, and nobody got time for that in a given plant. If you could see this image, you would see that there are very similar patterns in there. And those patterns are the energy demand, and they will always look the same whenever a peak load was occurring. However, they weren't even, because of a real use case, they shouldn't even be there. It just was a control problem that they didn't discover before that. So they burned money for a peak load that they didn't even need to have. They just had a control problem in there. So yeah, that's also pretty simple. Once you found it, the way to find it is the hard part. Yeah, that's the third use case that I brought with me. Next slide, please. So implementation is a big thing. Again, I try to describe that it's incredibly heterogeneous, and we try to simplify this process of connecting a new plant to our system, to our energy efficiency as a service. And that's we also try to cover that in just 3 months and already provide value very early. Just because we are in a group of people that are interested in AI projects, the one thing that we not try to do is collect all the data that is available and only then start processing it and finding things in there. This is the one thing we don't do, because it's incredibly frustrating for the customer, and it also is incredibly overwhelming for us, because if we tell them, give us all your data, and they actually do, we also can't really process that. So we try to start with the small parts, go top down, and then find routes through an existing system and always provide value over a continuous process. So if you took anything away from this talk, never ever say we need first all the data and then we can provide value. So we try to have a continuous process that starts very short and very easily. Next slide, please. Thank you very much. This is a screenshot of our platform. We basically ingest all the data. We try to automatically label it and then also have a no-code interface for engineers within our company, our partners, or also energy managers at our customers' companies. and they all work collaboratively in the cloud with their data and thereby label it. So that's a very large part of why we can even, or think even, we can promise what we promise. Yeah, automatic data cleaning is a thing, data warehouse, data value database, so external values that are needed for calculations, and a learning metadata storage. So we need to learn, and because people always talk about the same things, we just need to be very, very good at connecting those principles, these physical principles, with a new facility. So yeah, I think that's the last slide. Please get in touch or ask questions. I think I was faster. You saved me a lot of time. Thank you so much.
Yeah, it's time to to waste some time. To waste some
time.
No,
that's actually interesting.
To capture time again, but actually you received quite a lot of questions, 7 at the moment, and I have to talk like Louis de Funès because I think we only have 8 minutes left. First one, reducing energy for the cement industry does not seem to be very green at first sight. That's more like a comment. But
why not? Okay, I will assume that reducing energy for anybody is always green. You could obviously say, okay, let's just close down the cement industry, which we can discuss, but I think we are not there yet. I mean, we need cement. Everybody needs cement. Just think about where we always use cement and where we can save it, and then it's just not viable to say we don't need that kind of our modern life anymore. So it needs a lot of energy, which would reduce it. So yeah, I think it's green.
Yeah, of course, unless you have a substitute.
Yeah.
So next one. In which industries could you achieve the fastest rollout, and which industries are the slowest / toughest to crack?
So I would say automotive is the hardest because compared to, they have incredibly complex manufacturing processes. They are already exceptionally well optimized, not necessarily in regard to energy, because it just hasn't been a big problem for them. And last part of my answer, it still isn't, because energy demand or energy costs are rising, but still their product is relatively costly compared to cement, for example. So very complex system, very small share of their revenue is energy costs. That's the hardest. But the last part, that's my background. So I'm a mechanical engineer in manufacturing. So if you are an automotive manufacturer, I will probably still call you because I really like those plants.
Yeah, that can be arranged. I also spent 10 years in that industry.
Cool.
So next one, have you ever calculated your gray energy output, e.g. providing the services you do, and compare this number with what you can actually save in the industry? I know this is like the question, is the energy you require, is it higher than the savings you actually produce?
Yeah. No, we didn't calculate it. It probably is not comparable. I mean, we need to go to work, and then we have a cloud service, a cloud system working. If you save 1% of energy in a cement plant, like we can work forever for that.
Yeah, it's like how many gigawatt or megawatt hours are we talking about with a cement plant that you can save?
Yeah. We had a lot of interesting discussions. Should we go to a customer via car if it's faster, and how much faster does it need to be, and how much energy could we save in the time that we would sit in a train instead of a car? And yeah, it becomes really interesting very fast. But typically we shouldn't bother calculating that too much. Because again, what we individually do is negligible to what is done on the higher level.
Good. Now is a question that amounts almost to blasphemy on an AI panel. Most measures appear to be no nonsense inside. Given the energy cost associated with Bitcoin mining, doesn't a similar question apply here? Do we need AI at all? This is like asking the frog if you should, AI Austria, if you should leave out the water of the well. But what's your take on this one?
I might be inclined to do even more blasphemy. AI for the sake of doing AI is just is next to idiocy. It's not just the energy waste that we have in the cloud, it's just the waste of energy, the brain capacity that people spend on coming up with, oftentimes, and I'm talking as a researcher, or I have been a researcher, the time we wasted on coming up with arbitrarily complex use cases just for the sake of being allowed to use AI was a big waste. Many problems that are business problems can be solved more simply and should be solved more simply, and only after you have used all the technology that is not simple, you should resort to something that is a bit more complex. But that's generally a good engineering advice, I would say.
Amen to that.
Yeah.
So with regard to the time, honest answer, nice. Good. This was referring to the last one.
Ah, okay.
Yeah. Oh, this is now the most EU question you could imagine. Did you receive government grants? If yes, which?
Yeah, sure. The biggest part of our funding round is AWS Seed. Thank you, AWS. And also the Wirtschaftsagentur, Wiener Wirtschaftsagentur.
Vienna Business Agency and Austrian Business Agency.
AWS, not the Amazon guys. So Austria Wirtschaftsservice. Yeah.
Great. Then aren't your partners cautious about sharing their knowledge with the world with you as the intermediary? What's in for them?
Sure, they are cautious. What's in it for them? Energy efficiency.
Savings. Are there any, let's say, industries which require special measures?
Yeah,
like
I mean,
you mentioned automotive, for example,
yeah.
And automotive could, in theory, you could deduct from the power consumption levels how production output is in specific plants or production lines.
Yeah, so basically the same questions that have already been given. Just to answer this, do people have concerns? You can or you cannot use your data. If you decide to use your data, you can either have a lot of people in your company that do that. If that's not a viable way, you have to get other people to work on it. And most people in the manufacturing domain need to do the last thing that I just told you. And our job as those that provide this service to them is to make it secure. And just to refer to this, can people deduct IP about the manufacturing process from data? In principle, they can, but only very, very rarely do we really need to use the high sample raw data from a core manufacturing process. Until we have that problem, we can save so much energy that we didn't even have to bother about that yet.
2 minutes, 2 questions. Could you explain how cement or semiconductor use cases are consuming less energy versus uses the same amount of energy when it's cheaper?
I didn't get that.
Me neither, it doesn't make sense.
It probably makes, but I don't understand it. Send me an email. Or send me an email, I don't know where you are.
LinkedIn always works.
Yeah, also that.
Then last but not least, this almost looks like a business proposal. Are you considering or open to venturing into the Middle Eastern markets?
Why not? So we're yes, like please send me an email.
and water is wet. No, thanks a lot.
Yeah.
Yeah, I mean, we are now really up to the minute within our time budget, which is very rare. Does anybody of you have additional questions in the room? Because otherwise, it's like with a marriage, if there are no further questions or disputes, then so shall it be. So thanks a lot for tuning in today. And
thank you.
If you have any questions, shoot us or the organizers some emails. So thank you and enjoy your evening. Bye-bye.